start sending the output again. Yeah, it's like you have to have the page open before it actually starts broadcasting. That's crazy. Okay, there we go. I think YouTube's good now. Let's go back to my channel. Okay, yeah, there we go. All right. Well, another day. I'm about to say another day, another dollar, but we ain't making money off of this. Another day, more code. Let's move this down real quick. So I've been working on expressions. It's getting there. It's getting there. I believe I'm able to parse like all of this. So this is like a combination of like postfix operators, prefix operators, function calls, parentheses, like method or field calls. I think the precedence, yeah, the precedence is right for that because the dot is before that. I gotta mess with some of the actual precedence rules after I get everything working. But yeah, let's see it work though. So we'll clear this and redo it. Yeah, there we go. See, it works. So these are the tokenized results. We have all the tokens, and then I put a little thing showing like how many expressions or whatever were generated. Yeah. Let me make sure this is right. Let's see. All right, so I would oh, it's kind of hard to see, huh? Oh, you know what I could do actually? Can I have it like I can have it like that? Hell yeah. Okay, so I would expect A plus B to be together at the very least. So, where's the A and B? They are together. Good. Okay, what else should I expect to be together? Probably the function call. Yeah, function call is all one bit, and that should be combined with this. So this should be together. Where's the V? Yeah, we have the prefix operation with the V, and then we have the multiplication combining this prefix and this function call expression. So that's valid, and then all of that should be wrapped up and with a subtraction, I believe. So this is the right hand of that. Where's the left hand? And subtraction, yeah, with this. The C and the ASDF should be before the prefix. Yeah, I think it's here. Yeah, C and ASDF are combined, and then wait, is that a binary operation? Oh yeah, it's a binary operation. Oh, what am I talking about? Of course it is. Oh, yo, what's good? Why are you making a language just for fun? Yeah, I mean, I guess for the learning experience, it's probably like the best answer for that. But I do have like a particular reason like why I'm making it, but I don't expect anything from it. I just had an idea for a language. I was like, yeah, let me do it, you know. So yeah. I mean, if you want me to like tell you about it, like let me know. Oh, welcome to the stream, by the way. Like, I think you're on the YouTube side, aren't you? Why are you making it like okay, yeah, you're on the YouTube side for sure. But yeah, right now it's still kind of early. Like, you know, I'm just writing the parse tree / AST. I guess because I'm using Pratt parsing, so it goes straight to sort of like an AST syntax for the expressions, at least. I'm still figuring out what actually needs to be like cleaned up to be considered like a proper AST. I don't know. You're still parsing? Do you have code generation yet? Not yet. I'm expecting like the main output just to be a transpiler to see. I do want to do code generation, but that part will probably just be for fun. If I ever actually like take it seriously, I'm just gonna do transpiling to C and just go from there. But I hear you can learn a lot doing the code generation for like, you know, different CPU architectures or whatever. I was reading into like some of the like the IL or what is it called for the back end, like the three I forget what it's called, like the three structure, three operation thing, whatever. IL. I kind of want to learn how to make that. But yeah, right now I'm just verifying that this expression works. I got parentheses working. I got like infix operations. Those are good. Postfix and prefix work. Function calls work. I have this weird syntax here. I kind of just have like a generic function call with like an argument list inside, so I could put parentheses too. But of course, there's no semantic analysis yet, so it's all just expressions. no guarantee. Like, yeah, where is the C variable, right? Oh, I do have like a language spec though that I've been working on. I think I might work on that right now though. Let's see. Yeah, because I was trying to decide, and I think I'll just use the Rust linter since it's kind of close. At least the syntax is, anyways. Do you work on languages, Mob? Or what's your like your expertise? How do I? How should I do this other one? Wait, hold on. Language mode. Okay, there we go. I suppose I should work on like declarations. That shouldn't be too hard. I do want to be strongly typed. Although I do get that like being strongly typed kind of I don't know, makes like certain return types a little more unwieldy. I don't know. I'm gonna see. Because I do want to have like a first class syntax for, and let me see if I can find functions. I guess I didn't define it here, but was there somewhere else where I defined that idea? Let me see. Errors. So did I define it in errors? You know, this one I'm still thinking about though. I'm not even sure how I want to do this. This is kind of like a Zig kind of feel for like errors. But I know they have like, yeah, they have like error sets so you can combine them or whatever. I think I still need to explore that first. Contracts are the main idea. I don't know about these like labels. I'm still thinking about managed and config, kind of like public and private, but these have nothing to do with access, like access modification. They have a different semantic meaning. Modules, I haven't written anything in modules yet. Okay, let's go back to functions. I guess I didn't put my idea in there. Maybe I should put it in right now. So I was thinking like an or, like a bar, or like I guess the, what is it called? Because I know like the connotation of this is like a bitwise or, but I don't know. I feel like it's easier than doing this. But basically, I want to have like a union of this versus like an error type or something. I know Zig does something where it's like this. I guess that's pretty. I don't know. I guess it just depends on what my error system is going to look like. But being able to return like tuples And like unions directly from function, that's kind of useful. One thing I find very annoying when I was writing this compiler was just all the structs I have to write for everything. If I want to have like a return value. I feel like some of these error codes would just be better served just being directly into the code. But that's just my opinion. I don't know. I mean, maybe having the enum list is useful. But then you have to like put it into this struct. Like I want optional to be like the regular path. So you should be able to easily add like optional values and do like match statements. Oh, actually, you know what? Let me add something right now. New file. Control statements.kg or control mechanism. I don't know. And let's put in like a main. So we'll do fn main I32. Okay, let's put a comment saying description of. But yeah, if anyone has any questions about anything, just throw it at me, you know. It don't matter. Description of. Oh wait, how do I do this in the other ones? Control statements. Yeah, I'm gonna hold off on this part with this little thing. I don't know if I want to go down the zig route just yet. Okay. If while for I'm gonna follow like a, you know, like if I can get it close to C, then I'll try to, you know. One thing I will make different. Oh, you know what? Let's just do fn foo. And then I think it's a colon I32, I think. That was the syntax I used, right, for functions? Yeah, that's the syntax, okay. Void. I do want to have a void keyword. Let's see. Basic control flow. So we'll say like this. Yeah, I don't know why I'm like, I don't need to make this perfect. For some reason I'm trying to make it perfect. Let's just do it, you know. Loop control flow. I want to have like a match statement and a fall through statement. I think those being distinct is like worth it, but because I mean, like one thing is I feel like for the switch statement in C or whatever, it's like I feel like most of the time you just want to like match directly and you want to like verify that everything is exhaustively matched, right? It's like the regular And then sometimes you want the fall through mechanism. So I feel like having separate data structure, separate structures or syntax for those two, I feel like is useful. Match statements. Fall through. For and while. Do I want to do while? Maybe. Sometimes it's useful. I mean, I know it does make some code like a little easier to deal with to have a do while. I know it's possible to like get. I mean, you technically don't need any of these; you just need the while. You can get it. You can get everything done, but the other two are nice. Let's see. FN Baz B I64 void. We'll move these through. We'll have a match statements. Okay. We'll do a while loop first, since that's like kind of the base form, you know. Let's put the actual keyword. For loop. Do while loop. If, else, if, chain. I mean, yeah, that's basic conditionals. I don't really have support for ternary operators and expressions, but I think they said for the parsing it's not that hard to add it. Yeah, I'll see if I care, honestly. What is the word for this? Like, match and fall through? Case? No. Route statements? I guess I don't know. I don't know a name for this. It's probably like a technical name for this. And then this one. You know, I should start trying to get some of these things to compile. I think that's all the main statements I want. I'll define them in a second, but I think I have another issue I need to deal with right now. Right now, I want to delete this test.kg and just start checking the samples. But I think a bug I found was that for some reason the buffer is not expanding past 100 tokens for the Lexer. Let me see this error again. Yeah, I'll drop that bit. Same thing as this. Okay, so let's see it in action. Let me see if anyone's on YouTube or Twitch. Right now it's kind of late night, so I know people be watching from around the world, so times are different. Sometimes my YouTube goes down though because of like copyright. Why does it say ECS edition? That's crazy. Let's probably get a new label for that. Okay, well, YouTube's so good. Let me check Twitch real quick. Sometimes it be bugging and it don't tell me. Okay, yeah, it's just chill right now. All right. So okay, so the bug I was having. Let's try and run this again. How many tokens do I have? 72. So I think if I try and do this, I think it'll bug out. Oh, it's close to bugging out. Yeah, I need 3 more tokens. I forgot that I have to remove something. Let's do a plus. Yeah, there we go. Let's do that. Thanks, AI. Appreciate it. AI. All right, so that's. All right, let's try it. Okay, yeah, there we go. So there's a Lex error. It's the moment it goes over 100, and I think the reason is because my realloc call on my token array isn't working, or maybe it's not being invoked. So let's go to the Lexer, and first let me figure out how do I even, like, what is the okay, wait, let's just find the realloc call. All right, check for enough memory. Source consume. Actually, you know what? I should get like a consume method on my parser just to be safe. A defer keyword would be great. So am I not? Okay, so I'm reallocating the thing, but then. Oh, am I not updating the capacity? That's hilarious. Okay, that's hilarious, yeah. Okay. Let's just do size T, new capacity. Yeah, there you go. And just, yeah, just not do that. That's better. And do that. Was it really that simple? Let's see if that fixes it. Oh wow, it really was that simple. Okay. Good. Yeah, I'm gonna see. There's a guy named Zaku who comes in. He works on his like language too. But he's like way more advanced. Yeah, he was telling me about like having like fixed size pages and then like sort of like a linked list between pages to get like pointer stability instead of doing the realloc calls. I think in the back end, I'd like to have that as a thing, like period. Yeah. I think when I bootstrap the language, I'm definitely gonna like try and get that in because I want to have like some sort of like first class support for like allocators and like all that, and some way to guarantee pointer stability, because right now it's more of just like a developer what is the word, like developer invariant or like of the system, or like I don't know. I think I was listening to you, what I mean. I don't know. Okay, but good. That was kind of an annoying bug. Let's try and get some of these to work. Oh, you know what though? Like, this actually is a good spec for like different expressions. Let's actually make something expressions.kg. And then we'll copy something from pointers. Yeah, we'll get into pointer semantics in a bit. Function. Expression semantics. I suppose that's the right word. Yeah. Functions follow similar semantic style to Rust or other languages. Yeah. Okay. Expressions are similar to C style. Are similar to C in style. Currently they support, and I'll just list out all the things that it supports. I'll do that. Infix operations, A plus B, A plus bar. Oh my God, stop. Okay, there we go. Prefix operations. Where do you learn this stuff? I'm trying to learn about compilers too. There's like a few resources. I could give you like what I got, you know. Hopefully it helps. Yo, Blonder, what's good, man? How's it going? How's the what was it? How's life? How's the projects, man? Yeah, I'll just send you, like, is there like a particular thing about it that you're trying to learn, or are you just trying to like get into it? I've been using Geek for Geek and like Wikipedia, I guess, to kind of like get like an introduction on like the steps for compilers, I guess. I know Geek for Geek is not like the greatest resource ever, you know, like it's very surface level, but if you're just trying to figure out like what each step of the compiler is, this one's kind of helpful. I have some books, like a textbooks I've been reading, but they're a little dense. I feel like it's not super helpful, like when you're just trying to like get in there, you know. Yeah, you know what? I think this link would be good for you then. Because like what I would recommend then like is probably like this is what I'm gonna do anyways. I don't know. I've been reading through this, like it tells you like the different like compiler stages that do exist, and you can decide like which ones you care about, right? Like I think I'm gonna get most of my syntax working right now, like finish with the parser, and then I'm gonna move into like type analysis, or like you know. And for me, I don't really need the IR generation because I'm gonna go straight to C, like output, like transpiling it, right? But yeah, that depends on like what you're trying to do on the back end. I don't know if you're gonna try and use like LLVM, like a pre-built solution, right? I don't know. I don't know like your you know, like where you're at with it. Like what kind of language are you trying to make? Like for yeah, like what are you trying to make? Life's been actually going better. Okay, that's good. There's always a ceasefire. Okay, I have some extra room to breathe. Okay. Also been advancing on making the server client system for the voxel / game. Okay, cool. Let's go, dude. Wait, so how are you writing the networking code? Like, do you already have the low level stuff down, or are you using a library for it? Oh, okay. Yeah, I feel like past the parser, a lot of the intermediate stages are kind of optional. I feel like you could just go straight to code generation if you feel okay about like your AST. Or I mean, I'm assuming you're generating like a parse tree. It's kind of similar to an AST. It's just the AST is a bit more cleaned up. But yeah, I would say probably just get like an end-to-end compiler like working. That's what I'm trying to do right now. Yeah, I'm not doing LLVM. I'm not gonna lie. Like I can't stand the. It's fine. The thing is fine. I just don't want to deal with it. I'm not gonna lie. So no, I feel you. Prefix operations, so plus a. There's also some textbooks I could recommend. Maybe I'll send a link or something. Engineering a compiler, I think is the name of it. There's another one like the Dragon Book. But the Dragon Book doesn't really give you a lot of information past like a parser. Like it does go into it, but it really just focuses on like the lexer and the parser. So if you're already at the parser, it's not super helpful, to be honest. But I've been reading through this. It kind of like takes you through the route of like writing the compiler. Like that, I think the lexer starts with like regular expressions, and then like has you like go through like finite automata to try and develop like a like a DFA and then like a NFA. Which is like more rigorous and it's good, but like I don't know. I just at the end of the day, it still ends up with code generation anyway. So it's like I just write my own. Fuck it. But this book's pretty rigorous if you want to take a look at it. Hopefully that helped, Mob. If I don't know, if you want anything else, just let me know. I don't want to just inundate you with stuff. If you're like, eh. Operations. I'm using WinSock, and today I have already implemented TCP and UDP. Okay, sure. Oh yeah, you were saying you were using WinSock. I forgot. Yeah, and I also implemented sending entity data from the server to client. Now on to making chunks sent to the client. I got you. I assume there's like there's sort of like you have to decide which chunks make sense to send between clients, right? And the server would have like the authoritative version of whatever the state should be. It was interesting with building games because you kind of have to have like the immediate response on the client side, but then the server has to be the authority on like what actually exists in the world. Like I assume like FPS games, like, you know, you're just managing like the people running around and the bullets, right? And that interaction. But the state of the world doesn't really change too much. Well, I guess in the very, very, very basic version. Of course, nowadays it's super complicated, right? Infix operations, postfix operations. I don't know, like what type of like for parsing. I wrote like a little language before myself for like scripting mob. It's like and kind of like embarrassingly messy, I'm not gonna lie. But in that one I kind of sort of just winged the parser and the lexer. I just made it up. So now with this one I'm trying to like actually use like documented like methods for parsing. So I use Pratt parsing. I don't know if you want the link to that one. But you can get like that's what tells me about like this stuff, like infix, prefix, postfix operations. Pratt parsing supports like basically all these like out of the box. You can also do like other recursive like bottom up or like top down descent parsers for the expressions, but it just depends what you care about. Postfix operations, infix. Was there something else procedure calls. I'll call it function calls, just consistent. Call ups. Baz. What else? I don't even know if that really deserves to be its own thing. I don't know. It's a bit rigid. Have you seen the I go by lots of names? Oh, you know, I saw that before you even mentioned the name, actually. Like, I didn't even know that I saw that video, but I guess a week ago I saw it about Rust. It was something like Rust, I don't know, it was just like 10 minutes of like, yeah, just like fucking around, right? But yeah, I don't follow the guy super closely though. I think it just popped up on my timeline. What other expressions was I gonna support? The dot operator is an infix operation. Oh, parentheses. I do have parentheses. Parentheses. Rust plus plus. And if it's finished uploading, then World War III and the second. So it do be that serious, don't you know? Don't. Who's gonna be the first person to Rust plus plus? That's crazy. What's a good example of this? A plus B times C. There we go. Or maybe they'll keep it under wraps. No one will see it like Jai. It's still an open beta now. Oh no, it's not open beta. It's still closed beta right now, right? Yeah. I don't know. I feel like we gotta worry about the AI first before anything. Let's see. Dot operator. I don't even think the dot operator is worth mentioning, to be honest. Like, yeah, we get it. There's members, you know. This is just like an amalgamation of all these things. Complex expression. Oh, I could like D minus. Yeah, there we go. Something ridiculous. And we'll put up parentheses around this and this. There you go. So how's Cargano been going? Is the Vulkan renderer working, or did you still not finish it? Yeah, so I kind of stopped working on Cargano. I think I'm just working on this language now. I plan on building the engine on top of this language, but we'll see, because I guess I can show you like where the state of the engine was before I switched over. Learn source. Oh yeah, I was reading Hazel. Yeah, so the recent rewrite is here. Yeah, I was writing it in C++, but I was trying to do like a C style C++, you know, keep it simple. But do you see these asserts? Just assert after. Oh, well, this is the test page, anyways. Let me go to like. I was writing like my own containers and stuff. Pretty fun. And I was kind of going half in on some of the C++ ways of like defining these things. The dynamic array is the one that's kind of like a bunch of stuff. But yeah, I just got annoyed. I got annoyed by like C++ and like I think the nail in the coffin for me was the fact that a constructor doesn't return a value. I think that's what pissed me off the most, and I left because I was trying to verify some information upon like initialization of a data structure, and there's just super conflicting like answers on like how to handle that, and most of the idiomatic ways of handling it is just to like say, okay, well, don't ever call an init function. You want to call a constructor so that the invariance of that class, or like what you expect the state to be, is like always valid, right? But when I initialize a class, I want to initialize it with like some data, then like an allocator and stuff. And the way that the C++ standard library does it is they do it through like compile time allocators like std blah blah standard allocator, whatever, right? And I don't know, like the only way to like get error checks for that kind of thing is basically to throw an exception. Like that's the only idiomatic way to do it. Everything else you can't check for a correct state upon construction and then return that value unless you use exceptions. And that was like the nail in the coffin for me. Just pissed me off, man. I'm like, I just like all I want is to preserve my invariance. You know what I mean? Like I just want to have like a class that I can say is safe. I don't know. C++ was so bad you're making your own language now. I guess so. Yeah. I don't know. Like I was like, I guess I'm writing C style C++, so I said I might as well just go to C. But once I reached C, I was like, I want my invariance, man. Like I want to have like some confidence that my code, like, because like in C, like, yes, you can do like public API stuff and everything. You know, where like you hide the implementations behind like a library, you know, like a header file distinction, whatever. But inside the implementation file, you can just do like fuck all, you know, like you still blow shit up. Which I guess is just like a developer discipline thing, but like I'd like to actually verify these things, you know. I don't know. Sorry, I just started like cussing for no reason. My bad. Said like Jonathan Blow. That guy is like on a whole thing, you know. Wait, so you basically followed C++ common practices? Yeah, it's like I feel like if you really want to write C++, it's like you, because you know, like in C++, like you basically write like your own version of the language, right? Like everyone kind of has their own little version of the language. Like some people use smart pointers, some people use some people don't, and they're like, I will do it the C way, you know, and then everyone argues about it. Some people like swear by like the new features. Some people are stuck with a certain subset because the compiler is stuck there, you know, for like business reasons or whatever. But yeah, I don't know, everyone just ends up with their own like little version. But I feel like if you really want to write like good C++, you have to do it the idiomatic way, and that means like you know, like everything is RAII. You have to use like constructors and destructors for everything. You have to use like inheritance to like some degree, you know, and the new features just feel like tacked on top of these systems, you know. Like one example in particular is like the what is it called, the one for like concurrency, like the co-yield, and you can like, you know, you can write them on top of like a thread pool, coroutines. Yeah, like the coroutines API just pisses me off. Oh my god. Yeah, no, I feel you. Like I like certain features of C, like C++, you know, like what is it, like function overloading. That's super useful, and it's annoying that you have to write a separate name for everything in C. It's ridiculous. Macros are gross, and I'm sorry, I know like other languages have like hygienic macros and macros that, you know, like are better and actually have information about the type system, but even with that, it still obfuscates like the control flow of the code. It's just sort of like something that happens with macros. You can't. That's just like a trade-off you have to take with it. I'm just not a big fan of it. I do like code generation, but I want to do it in like a particular way, not with macros. I don't know. I don't really care about what some people think is best practice. I just code how it ends up comfortable for me. Like my coding style is very C-like. No. I mean, that's fair. That's kind of like how I got to a certain point with like my code base, right? I was like, I'm just gonna write it my own way. That's why I was writing like init and terminate, even though it's like non-idiomatic. And like inserting runtime buffers, like allocators, or I don't know. Yeah, there's a bunch of best practice stuff. You could probably read from Bjorn's thing or whatever. But I feel like I was literally just hitting a wall with the design of the language, where like the design of the language is objects and like object hierarchies, like at the end of the day, right? And certain features in the standard library and certain features in the language are just built around that idea, right? And you can just not use those, but you still are going to hit some friction, you know? And now just getting tired of it. I like C with generics, not that. I see with generics, not that yucky macro. C3 might be good, but I haven't gotten to it yet. Is C3 a language? I know there's like a few like C replacement languages out there. I don't know if Odin is trying to be a C replacement. I know Zig kind of touts that, especially like they have like their inbuilt like C compiler, or I forget what he uses, but they store in the standard library common stuff, so you can just compile it directly in Zig. That's such a cool feature. I heard Carbon is another one of those, but I haven't looked into it. I looked into using those other languages, but there was just like one particular thing that I kind of felt strongly about, and I was like, yeah, I just want to wrap my language around that. So that's why I'm here. But yeah, I'm like, for my language, I plan on adding like a certain level of reflection. I mean, not full reflection. I think full reflection is a bit too much. But some level of reflection, just to make like it is ridiculous that in C++, still in modern C++, you can't reflect on fields to do like serialization. So that's going to be very important. I'm hoping with the design of the language, I can get to a point where it's just super easy to write like my code, you know? Like in my original engine, I just have like, I think half of my code base is literally just like using the UI library, if I remember correctly. Yeah, C3. But yeah, I haven't heard of C3. I might take a look. I think Odin is trying to go its own way. Zig wants to be a better C, and Carbon wants to replace C++, but it's far from completion. Oh, okay. Yeah, the reason C++ has no reflection yet is because it's a compiled language, not a managed language or interpreted. You can't add reflection to a compiler, if I'm not mistaken. Well, you can still project some information from the AST and from everything, like as long as you like provide it to the end user, right? But I agree, you can't do full reflection on like a compiled language. But I don't want full reflection. I think full reflection is too much. I just want to be able to reflect on like what the field types are and everything, and then use that information. That's definitely doable, and that's probably that's the minimum that I need to get like automatic serialization done. Or automatic, what I mean is like, you know, you can what is it? You know, you reflect on the types, iterate over them, and do something right with it. I think Odin is trying to go its own way. Yeah, I know Odin has a very particular stance on his thing, and it's not really trying to be like super security. I think Zig is really super intense on like error codes, and it is yeah, it is trying to like give better tools than C. Yeah, I'll take a look at Carbon C3 later though. I don't see why you couldn't add limited reflection by including meta. Yeah, that's what I'm saying. That's all I think I need. Like, full reflection is like modifying like the source and like doing, you know what I mean? I don't think I need all that. And actually, if I need to like recompile the source, I have other ideas for doing that than just making it arbitrarily like reflected. You know, I don't know. Oh yeah, what's up, Adam? How's it going, man? Hey, it's been a minute. I see, man. Oh, speaking of which, honestly, now that I'm making the server, I will take the opportunity to switch to using uint64 instead of ints for chunk coordinates and block. Oh, does the extra space help in your situation? Doesn't the upcoming C++ 26 have reflection? It does, and it actually has the other feature that I'm working on in this language, contracts. But again, it's like I honestly feel like it's too little too late. I mean, it's good, you know, but what is it called? I don't know. Like, again, the idea of my language is like is solely written around the idea of like design by contract, right? That's like the core idea. I want to be able to travel in the 64-bit coordinate range. Yeah, I mean, that's fair. Yeah. It's a big world, man. 18 undecillion or something. How's it going, Adam? How you doing, my dude? Yeah, I opened this for some reason, but I don't know if I want to show the whole code base or whatever. This just became like a bloated mess. I think that's why I wanted to say it, to be honest. Function call operations parentheses. I think that's it for now. I think I'll stop there with the explanation. Fn main I32. And let's just copy and paste these, yeah? And I'll get rid of this test kg thing. Maybe I can actually make it logically consistent for once. Let's try that actually. Yeah, you know what? Let's actually make it logically consistent, yeah. So there's A, B, C, D, V. We'll keep everything as integers for now. So A, B, C, D, V. A, B, C. And we'll keep everything, yeah, just basic integers. Keep life simple. D, I32, and then V. F looks, parentheses, postfix, function call. And I had this kind of thing just to like showcase I could do that, but honestly, let's just make it a regular function call. Yeah. Baz. I should also check if I can put arbitrary expressions inside of here if it messes it up or whatever. So I think we just need the member thing. I think I'll leave it alone for now, actually. Just because I don't really have a mechanism for that yet, so I'll come back to it. Baz ASDF. That's about it. Then Baz. A I32, B I32, C I32. From my game engine, the 2000 engine, I had a super basic reflection, which really is more like a property system rather than full. For sure. Yeah, I remember we're using like macros for it. I feel like I remember you told me about that yesterday or the other day. Just return void in this case. A plus B plus C. Yeah, we can just dead code for the win. Let's see. As FN ASDF. We'll just copy and paste this, yeah? Also should handle... Oh wait, this actually should return. My bad, because that's what makes sense in the expression, doesn't it? My bad. I32. Return A times B times C. There we go. And let it overflow. Okay, let's see. So, Baz, ASDF. V is a value. We have a bunch of literals. D is a thing. Okay, I think that's it. Functions are here for... I'll put like a note. Notes, method, functions here for function call illustration. Maybe it doesn't need to be mentioned, but whatever. Currently supported expressions. Like this. Okay, let's actually see if we can just get this to compile too. I believe functions are fine. I don't think the key... We don't have a return keyword yet, so I might have to skip that for a second. But let's see if everything else returns properly. KG Lang. Oh yeah, how's it going? Half Woof? Yeah, I've been chilling. How about you? Yeah, I'll show you what changed. You know. Yeah, every in-game class inherits from reflectable, and some macros like reflect begin and reflect end that really just expand to overriding add properties. Yeah, that kind of reminds me. There's this other guy on YouTube I follow. I forget his name. But he does something similar for like his like reflection, you know, so you can get the data, and then like I think he has something where he uses that to generate like I'm GUI controls for that like type. It's also using like macros too. It was pretty cool when he demonstrated it. Okay, so /samples. Let me just test this real quick. How Wolf, and I'll show you. Basics, and then wait, which one is this? Expressions. Oh, that's embarrassing. Something failed. I also need to get like better like error messages soon. But let's see what might have caused an issue. I mean, these should be fine. These should be fine. Okay, let's try to get rid of this, and we'll see. It's the first non-expression code I haven't tried to make work. Okay, so let's see if that was the issue. I don't know. Let's see. Oh, really? It wasn't? Okay, wait. Hold on. Really? Pretty sure that should have worked. Wait, okay, let's just take this bit and move it over. And let's try it. Because this was working earlier, so. Wait, why is this failing to parse now? What? Is it because of the parameters? No way. Oh, it might be the parameters, actually. That's the only thing that's different, really, isn't it? No, what? Was it this that changed? Maybe it's the function calls are messed up. Okay, that's just weird. Hold on. Let me go to my source control real quick and get the old file. Because I want to get the exact old file that I had. Okay. I know this one worked, so let's check it out. So I don't know if I regressed or something. Okay, that one works. What is the difference? Oh yeah, how woof. Okay, so let me show you real quick what I did. So I got like these types of, I mean, you wouldn't believe me because it wasn't working for forever, but I got these types of expressions like parsing. So we now have like function calls, we have like prefix expressions, we have postfix expressions, we have like dot operators, we have parentheses working. So we called that, and then now we get like basically like the parameters, the two parameters, and then I checked it earlier, it should be working, where like the parentheses were like making sure that certain things get called first or in the correct place in the AST. But yeah, we got like function calls here, binary operations, postfix on top of it. So yeah, that's pretty much what I got done the past like day or so. Are you designing your own programming language? Yeah. Right now I'm I mean, right now I'm dealing with a bug, but I'm just working on the parser right now. I don't know what that means. Oh my god, function calls. I know the yeah, like I could kind of break it down. Like, so if you take a look here, so if I break this into pieces, right? So you have like infix expressions. That's basically just a plus b. That's like this part right here. We breaking it down. Prefix and postfix. It's basically like, yeah, there you go. Yeah, you figured it out. Good job. And then postfix is like ASDF++. Then we have what is it? The function call. I mean, you said you understand the function calls. So I don't think I need to go through it, but yeah, basically just this. And what was the last thing? That, and then just parentheses. I mean, you know what the parentheses are. But my point is, you have these as like individual expressions. So if you take a look at like the visualization, or like this is like called pretty printing. But it just outputs like the expression. So if you have like the function right here, function 1, and then it has a return type, it has a list of parameters. They're all kind of like on the same line right here. Let me zoom in actually. Yeah, you have the like return type, parameters, and body statements, and there's only one body statement being parsed right now. Everything else is commented out, so it's just removed. Yeah, and then you have like binary operations of like minus plus this whole thing right here is the left hand operand, and the right hand operand is this whole thing. and they just basically the leaf nodes, like when you actually go to like evaluate expressions, ideally you would deal with the leaf nodes and then move up the tree until you get to the root, and then you return that value, right? Well, at least in the actual control flow of like the program. Of course, not all that can be like collapsed down, of course. It's an expression at compile time or whatever. Funky style. Wait, I think I missed Blonder. Really, any general purpose engine needs a basic property system, not Unreal's dodge and heavyweight reflection. Just some basic property. Yeah, like that was one of those things that I understood. Like I really needed at like a base level, at least at the language level, so that I could build tools on top of it. Like add you know, not so much boilerplate code everywhere. So annoying. Oh, prefix and suffix. Good point. Yeah. Are they like what is the term for that? Like words that are like opposite? Prefix and suffix. Where did I get postfix? Postfix? A word? Oh, are they synonyms? Okay, it's a synonym. So technically we're both right. Where did I get postfix? Because yeah, in grammar it is suffix. I have heard Golang, but this is my first time watching some of this type of coding. Last time I saw a basic language, I think in Stranger Things. Oh, for sure. Yeah, I mean, I also don't know if I'm like any sort of authority at all. I'm kind of just winging this, so I don't know. Yeah, I don't know where you would go to like see this type of coding. I guess I feel like a lot of the knowledge on this topic is kind of like spread around. Like I feel like it's there online, but it's just like you have to search for it. Like this stuff is cool, but it's not super deep. It's just kind of like telling you like what things are, like definition wise. Wikipedia is kind of fire though. Yeah, okay, so I'm trying to figure out what the hell went wrong with everything else when I was trying to make it work. Let's see. Yeah, what is the actual difference between this code and this expression code? Was I doing something wrong? No, it's still formatted the same. FN main I32. You have opening closing braces. We have the expression, and I don't think anything here breaks anything. Yeah, that's so confusing. I don't know. I'll figure out what the issue is. Can you please tell me a summary? Like, what are you building? So I mean, a lot of like the syntax and everything, I don't really have a strong opinion about it. Like I'm kind of going from like a C standpoint, you know, like as far as like, the syntax, like I want to do C, but also in the kind of like a modern C way. So it looks a little bit like Rust right now, I guess the syntax wise. But again, I don't really care. It's just sort of like as you get something on the screen. But as far as like the core like idea of the language, or like what I feel like makes it like unique, or why I care about making it, I want to make a language that does I feel like if I say like automated testing, that has like so much connotation to it, like designed by contract. That's more of like an established field. Yeah. it has like design by contract and property-based testing built directly into the language. Another example of a language that has that is Haskell. But Haskell is a functional language and kind of tough to get into. Let me see if I can find a Wikipedia about it. I'm assuming a bunch of you guys know about Haskell. I'm not going to try and explain the whole thing. But yeah, the two ideas are design by contract and in turn property-based testing. So design by contract, this is like the core idea of it right here. It's that thank you, AI. Fucking AI. Fucking clankers. the Skynet's gonna come for me, man, I swear. Anyways, yeah, it's preconditions, postconditions, and class invariants. I mean, it'll tell you the same thing on this is actually pretty accurate if you like Wikipedia or like some other documentation discussing it. It's this, yeah, same basic idea. So it's preconditions, postconditions, and class invariants. So preconditions and postconditions, those concern like functions, right? So if I had say, I don't know, some arbitrary function, Baz, right? Preconditions are kind of like asserts. It's like you have an assert, and then you have like this I32 right here, right? And you assert that A is less than 100, or is greater than 5, is less than, you have like some kind of bounds checking here, right? I'm just explaining asserts. Everyone knows what asserts are, right? But this is a precondition, right? And then you have like postconditions. So these would check after the return statement, either in some other block outside of the function call or whatever. I'll figure out how that works. But yeah, you just assert some state of the world beginning the function and then ending at the end of the function, right? That's what preconditions and postconditions are. And then you have a class invariance. So these are just things that you assume to be true throughout the execution of the program for that particular data, right? A good example of sorry, I think I heard a message, but I'm just gonna finish my thought. Let me find a struct real quick, or let me just do like a struct, I guess, like a C style struct or whatever, or C++ style struct. If you have something like an array, right? Like an array has like a data pointer, and then you have like a I8 U8 pointer, and then like a length, right? It's I32. There you go, right? So an invariant you would say for this class would be what are you talking about, AI? That the length matches the length of the data in the data pointer. That's like something that is maintained by the code itself, right? And could be logically broken at any point, right? But you sort of assume these things to be true so that you don't have to think about this type so often, right? You don't have to always be managing the length every single time you do something with the data, right? But if you don't use it, is it the big CEOs might get the idea that we have we are forced to use it. Damn. I mean, yeah, we'll see as AI, gets. I don't know. Definitely, there's a whole argument of like us getting reliant on AI and then not being able to code. I don't know. We'll see how everything progresses, I guess. Okay, but anyways, I guess I was just defining like what an invariant is, and what is like a precondition and what is a postcondition. And an invariant doesn't have to just relate to data itself, it can also relate to just general state inside of your code, like period, right? So if you have like a system, you might assume certain things about like how the system works and what things happen and what things don't happen, right? Like, say if you had like a pointer to something, like a raw pointer to something, if you store that pointer inside of some other class, you kind of maybe assume that that pointer lives longer than the lifetime of the data class you inject it to. So it's kind of like dependency injection, right? There are like semantic ways to enforce that in different languages, you know, smart pointers, whatever, like in C++. But yeah, that is an invariant though. Like you basically are saying like that data is going to outlive the class that you injected into, right? So that it can always like successfully access it. And another assumption they have on top of that is that that pointer is never going to get moved around, right? Like the underlying data is stable, or the underlying allocation is stable for that pointer, right? So you're not going to get realloced and then that pointer's been invalidated, or you're not going to get, you know, I hope you guys get what I'm saying. Anyways, that was a big like explanation of these three things. The idea behind like design by contract is basically to formalize like these three ideas, right? And basically say that it's like a language level construct like in the language, and then we're going to enforce that, right? So like one common thing for enforcing invariants like in object-oriented languages like C++ or whatever like thing they have like private and public accessors and stuff, is you sort of draw up like a wall, right? You say like give me C++ class with public and private accessors. Come on, AI, you got this. There you go. So the public and private distinctions become like the wall in which you can like mess with the data, but it doesn't actually enforce any invariance by itself. It just says this is how you access the data. The way you enforce the invariance is actually like the assert checks that you do surrounding the method calls and like what you actually do in the code, right? But at the very least, C++ gives you a way to like build up the walls so that you can't just arbitrarily go in and mess with the data, right? The issue with this though is that this arbitrary like choice to make things public and private causes a lot of issues with maintainability later on, right? Like if you want to like add access to like some unique way of messing with the data, then you have to add an extra method to the class, or you might have to rewrite an existing method so that it doesn't break with any new methods, right? And then when you do that, you can break implementation in other files or whatever, right? Also, the fact that public and private is conflated with invariant protection is just not true. They are orthogonal things. You know, like protecting your invariants and access control of data are like two different things. And you can handle them in separate ways. They may interact, but they're different, you know. So the idea behind my language is basically, and now I'll actually kind of give the kind of like point, right? The idea behind my language is basically to do like C style code, right? Where basically you just have methods. You have methods, you call methods, whatever. There's no association between like there's no methods like this. There's you have like free functions. Everything's a free function, right? How do I say? And at that point it's like, okay, we'll just use C, right? But at that, like, you can't, if everything's like super accessible, right? Like, and then I'm saying the structs are all like public fields. So if you have a struct, everything is publicly available, right? So in this way, you can't really protect the invariance, right? Because you can just keep adding functions that modify this data. So the way that I do protect invariants is through contracts. And I have some example of like contracts, I think here. I'm still messing with the API, so I don't know like how it's gonna exactly look. But the idea is you create these contracts and then you give them sort of like scopes to like look into, right? So like a contract could check either a precondition, a postcondition, or an invariant. If we're just looking at an invariant, we could do something like watch write contract, something like this. Where basically you have like this this contract array valid. It just checks if the array is valid, right? By basically just saying like it asserts that the length is less than or equal to the capacity, and then the data is not equal to null, right? Whatever invariants you have for that type. And then you add this like write, watch write operations to the contract, and it basically just says that, okay, now for that particular data, for that particular type, I'm gonna insert invariant checks or like asserts all the way throughout the code base wherever a write operation occurs automatically, right? The way that actually is gonna happen, I'm still kind of like designing it because there's some weird like isms with that. But yeah, the idea is you write your invariant once and it's checked throughout the entire code base. Instead of trying to search throughout the code base and try and find every single place where you want to check if that invariant holds. Yeah. I don't know if anyone are you guys still here? You guys still like watching? I don't want to keep like going if no one's like you know, following. I'll just wait a bit because I do give this like spiel sometimes. Oh, for sure, Bond. I mean, are you interested, or like you want me to just keep coding? Like, I think I remember I did this thing, or I told you about this the other day. Okay, for sure. Yeah, no, I'll do your thing. Do your thing. Well, if anybody wants me to like continue discussing, just let me know. But again, I feel like this I don't know, this stream and the way I'm discussing it is not really the best way to explain this. What I would rather have is like a dedicated video, like showing like the actual language working, plus like explanations on why I feel it's important, right? So I just want to get there, you know. Okay, so let's get back to debugging. But if anyone like is curious, just let me know, you know. Current support expressions. So yeah, I was trying to see if this, what's wrong with this. So we'll get rid of all this. Why does that not work? Okay, that works good. Okay, actually, let me find where this is actually like throwing an error. You know what I should do? I should start adding some printf set like error conditions. Let's just do that now because it's a little ridiculous. Like I can't even see like what's going on. I'll kind of go through this one by one. So allocations, we have allocations. Add expression, cool, pop, get add expression, add parameter. It's not really a failure case. Oh well. Yeah, I'll just put the printfs right here. Printf. add definition pre-alloc failure. I don't want to have any more state than that. Just this. Yeah. Keep it simple. Where do you want to do it? 86? Well, don't replace it, yeah? Why are you replacing it? There you go. Yeah, I could just search that. Also, maybe some reflection around like where we're at would be nice too. Maybe I'll just do the function name and then do like the error code that's passed back. So parse arguments list allocation username. Yeah, I'm definitely gonna have like an error system or something when I bootstrap this. I don't know what it's gonna look like, but I'm gonna have something. Yo, Dr. Elliot, how's it going, man? Yeah, I know it's like 2 hours ahead, right? So it's like six something over there. Starting the day. Yeah, I'm gonna put the method name. Add arguments. Something like that. Hopefully the AI can catch on to my pattern. Yeah, there you go. Add expression, add statement. Yeah, it might be useful to know which function I'm calling it from. I don't want to add too much information though. I just want to know like the function that's called and then like what the error was, and then if I need to make the error more specific, I can come back. Probably don't even need the method call if I make sure the names are distinct enough, but who cares? Who cares? I'm just trying to find a bug. Yeah, there we go. So we'll do this. What are you talking about? Expression? No, it's an argument list. Don't have like underscore func. Yeah, that's true. I don't know if I want to go through the complexity because this isn't like a robust thing. I'm just trying to. I'm gonna throw out these printfs later, anyways. Yeah, I'm pretty sure C does have that though. First argument list. Yeah, I definitely don't want to just have like arbitrary logging everywhere. Like, no, I'm good. Yeah, again, I want to, again, I'm going to bootstrap this language, so I'm going to come back and rewrite this. I want to find like a good solution that I feel like good about, but I've been looking at like the way certain languages do it. I don't know. I don't know what I want. Are you not using AI to build? I just use it for like stuff like this, you know, like what is it called? Like I ask it questions sometimes, try to get it to direct me to certain things. I let it write me like repetitive code like this that I'm gonna throw away anyways. Might as well save my fingers, right? I only want air conditions. Gotta be careful about that. But generating the code, I don't want to do that. I'd like to understand the code. Printf. Throw it all out. Maintain your sanity. Yeah, honestly, this C code, like, does kind of hurt my stance. Stop doing this. What are you doing? What are you talking about? Replace the return statement. It's trying to sabotage, I swear. Yeah, like a closed parentheses. Don't. Yeah, can you fuck off? Yeah. I get that I need better return statements, but like, leave me alone. Yeah, left-hand side not found. Yeah, earlier when I was like dealing with a bug, it just kept saying like, oh yeah, fail with error code 2. I'm like, oh. Well then. This is also a gigantic print expression method. I'm gonna break this up later. I also kind of want to do some code generation for the compiler at some point. Kind of like how some of the build tools for compilers do it, but I want to do it like my own way. And I want to stop doing this. I want to be very careful about code generation, because I'm not a big fan of macros. I'm like slowly realizing that. Like macros, like in general, you know, like. I think the new way is attributes. I want to switch my engine over to them. Meta, show, and editor. Yeah, I think I've seen. Some. Wait, does Jai do that? Does it do attributes? I've seen attributes in a few languages. Like, stop doing that. Alright, okay, there we go. Parse expression. Is this an error case? This is. Is this an error case? Add expression. Oh, this is the error case. Okay, so not that. No, Jai does wild stuff. Oh, yeah. Pseudo programming almost, yeah. I think one thing I do want from my language is like kind of like how Odin does it, where they don't hide anything from you. Like as far as like the control flow, I don't want anything that I inject into the language to actually mess with the control flow. That's kind of why I'm like I don't really want any sort of macros, like, period. Even though macros are very powerful. Yeah, I just kind of researched it. I've been reading some of the blogs from the creator too. Looking at some of the documentation. Execute Lua code. Like, oh, I thought you were about to say Lisp code, because the Lisp macros are ridiculous. Yes, invalid token state. That's fine. Have markers that execute Lua code. Hey, no, that's cool. Yeah. Oh yeah. I don't know. I mean, I remember this other guy who was doing macros that generate some of the IM GUI code that you can kind of like he injects wherever. I think he's getting pretty far with this project too. No more statements to parse. Yeah, this is an error case. Yeah, let's see how it goes. You know, how the reflection looks. Yeah, again, also the C++, they're trying to get what is it called? Contracts in too, which is what I'm working on. So I kind of saw like what their like design was for it. You kind of have to write them inline, which I'm not a big fan of. But maybe there's an option where you don't have to do that. I don't know. Do they say they're going to try and implement it pretty soon into the compilers? I don't know like how fast the pipeline is once they approve the feature and the compilers pick it up. Function, parse allocation function. Oh yeah, I was gonna ask if you use attributes in yours, but you said you want to switch over to it. Okay, for sure. Are you planning on like doing like a source code like run through to try to like pick up on those attributes like a pre-process kind of thing? Or would you use some sort of like C++ thing to get it to work? Oh, nice. Let me see. Using C++ 26. So which compilers support this feature now? Like did Clang or GCC get into it? Oh, they have a. Oh, you're talking about the things. For sure. Oh yeah. Yeah, that's basically it, right? Yeah, nice. Oh, they already have it? Oh, sure. Oh yeah. Print F. I already do that. My language has a libclang parser that runs and looks for the macros. Oh, okay, for sure. Yeah, I think I remember seeing that in your source code. Yeah, like I remember talking to you about that too. Yeah. Trying to see. I don't need to do these pop definitions and pop parameter thing, really. I mean, really, I shouldn't be doing this in individual things. I think I should just. I realized the other day if I have an error, I probably shouldn't even pop them to begin with and just keep them, and then I can read the state. But if I really want to clean it up, and be nice about it, I could just log what definitions, parameters, whatever already exist before a function call, and then just check afterwards, and then just pop the difference. That'd be way easier than whatever the hell I'm doing here. Yeah, that's an error. And then we'll see which ones get called in like normal execution for this. Yeah, the normal execution ones, I just want to leave them alone. Yeah, the only thing is we don't have reflection on these error codes. So that's the one part that I have to write in directly, but I think you're right though, Dr. Ellie. I should probably just do the underscore func underscore. Because I also want to include maybe the current token index that we're working with. Maybe in like a standard way. I'll run through it again. I'll see. This is the first pass, so whatever. But no, I think you're right. Okay, then allocate storage, initial storage. That's fine. Do I really need a message for the parse input? I already know it. Okay, sure, whatever. Yeah, okay. I don't know. GCC Clang it just uses the like property editable color that way. But I was thinking about switching it to like property color editable. Oh, for sure. Yeah, yeah. I mean, yeah, I think the second one is like more what is the word, like feels like properties, I guess. The first one feels like a function invocation. The property editable in color. But I mean, it's whatever floats your boat, you know. I don't know. All right, let's see. So the first thing I want to check is, yeah, actually, I probably want to see what current index we're at for these things. That would be useful. But yeah, let's go ahead and comment this out, and then let's uncomment this. Or I forget there's not a thing for that. And I'm assuming there is a key binding for that, right? Oh my god, fuck off! What are you doing? Okay, so let's see if we get any messages. Okay, good. So it looks like in the regular route, it doesn't message anything. That's what I wanted. Let's clear it and run it again. Yeah, no, I think we're good. 17 expressions, parameters, arguments, statements, definitions. Cool. All right. Okay, so let's comment this and then do this painstaking thing. All right, so let's see what's causing this issue. Parse expression close not found. Oh, really? Parse expression close parentheses. You know what? Yeah, I need to make these error codes more specific. Maybe like source information would be nice too. Let me look that up in the C docs. C underscore func and underscore line. Is that what it is? Or is that just in C++? What the hell? Okay, I don't need it. Yeah, it's like a preprocessor thing, so it just swaps it out, right? So func indicates that the program will strings, and then can you just give me the output, please? Okay, like, do I run it or something? Okay, let me just copy this code and see what it runs. Actually, let's see. There's my main. Okay. Maybe is this not defined? Let's see if the compiler yells at me. Okay, compiler didn't yell at me. That's good. So what did we get? In file source C function main. Okay, that's pretty good. Let's clean this up a little bit. So we'll say printf s. file func percent s. Does that include the? Oh yeah, it does. Okay, so percent d, something like that. I wonder, is there a way to like just get the resulting C string from this? I don't know. And then that. Oh, it needs to be defined in a macro too because it needs to be inlined in that location, huh? Yeah, it needs to be a macro. I just realized that. Okay, that's fine. Oh, wait. And then let's comma it with that. There we go. Oh, actually, let me see what it looks like too before I commit. Clear. All right, what does it look like? What about the extra? Oh, what was that? Okay. Clear. Source backslash main. 2. And then I can just give like some stuff. Right, some stuff. That's fine. All right, cool. So I'm just gonna yoink this. Yeah, I think in the parser, what we're gonna want is hash define print parse failure. I think you have to define the arguments for it, right? Kind of hoping that AI would help me with this one, because I always forget preprocessor stuff. Well, what would I need anyways? I needed the error codes. I need to pass that as a C string. I need the token ID or index. I can pass that in as a integer into the printf. Error code. Was there something else I wanted? I forgot. I already have the function. I guess that's it. Yeah. Okay. So EC percent. Oh, error message percent s toke idx percent d. New line is always helpful. Message toke idx. Okay. Does that work? I should probably test this out. All right, but let's do this. So print. So we just need, and then also I can just check if these messages make sense. Add definition Yeah, there's no token. Yeah, I just put -1. For the most part, you need this, but in this case, it's just useless, so who cares? Let me make sure my YouTube's still good. Sometimes the stream just shuts off randomly, so I just want to make sure it didn't break. No, it's still good. Okay, good. Oh, I got a subscriber. Thank you. I don't know. Oh, Arc Syndicate. Appreciate it. That was like an hour ago, though. I feel like you probably left. Where's my Twitch too? Let's see. Okay, Twitch still good. All right. Yeah, sometimes it like fails randomly on my thing. I don't know why. All right, let's get back to some C code. So that's still pretty accurate. We'll go through and fix this. Yeah, I want better error message names. I think this is still fine. Statements. Yep, good. Yep, still good. Good. Again, some reflection on the actual enum name would be nice in my language. Yeah, I don't think I want, I know in Rust they're tagged, their enums are tagged unions. I think I'm just gonna make tagged unions like a separate construct. I definitely do want tagged unions though. I just want enums to be enums. That's it. Still accurate, yeah. Is that an allocation failure? Check for expression. Commit allocation failure. I mean, the more specific, the better, right? I don't know. All right, let's see. Okay, is that right? Closing delimiter not found. Yeah, that's accurate. Yeah, I want to get this right, like right now before I start adding more features. Okay, so this one I think needs to be more specific. Handle expression not found in parentheses. Okay. Yeah, right hand side not found's not good enough. Wait, what are we doing? Expression not found. Okay, so parentheses expression not found. That's probably a better sentence. Where is it? Or I could just Go here. Parse expression parentheses expression not found. Okay. Yep. Paren. There you go. All right. Was close brace. Not found. Probably should go into its own method. I will probably do that pretty soon, but I just want to fix this bug. Not trying to change code structure right now. Close brace. Okay. Oh yeah, it's not a brace. Paren. Chip. I just realized we just been doing -1 for everything. Yeah, I'd like to know the index. At this point, we haven't updated the index, have we? Yeah, no, that's right. And then we go +1 to get past the parentheses. That's right. Let's go back up and fix some of these, like current index +1. Yeah, for the pretty printing, I always do +1. Let me make sure that's accurate too. Yeah, then we move past it. Okay, no, that's accurate. This one is current index +1. Is that true? Current range. You generate the argument. Yeah, that has nothing to do with the expression. Current index. The diff is so weird, man. Yeah, I was just adding -1 everywhere. Let's do. Okay, well, -1 doesn't. Yeah, it doesn't apply here in particular, but everywhere else it does. Okay, we will get through this. We will get through this. Okay, so again, what specifically is going on here? Parse expression. Search for expression following prefix operator. What? Look for some binding power for the prefix. Oh, okay, yeah. Yeah, okay. So let's do print parse failure, something like that. But also, I don't like this name. Wait, what is this? Expression following prefix. Prefix expression not found. That's a good name for it. Prefix expression not found. That's a good name for it. There you go. Prefix expression not found. Good. Okay, now this one's actually accurate. Just needs to change that, but yeah, that's actually accurate for once. Right hand side not found. So this is where we check for like an invocation, basically. Yeah, it's not right hand side. What is this? Argument list not found. So we'll say function argument list. Function call argument list not found. A very long name, but very accurate name. +1. Good. That's what we wanted. Right. Yeah, we want the original number. Whatever we got returned back is, yeah, probably not going to be good. And then let's rename this to, what do we want? Parse expression allocation failure. Because we're building the function allocation failure. Again, this could probably be helped by just splitting it into different functions, so I'll do that later, but again, don't want to mess with the control flow right now. Okay, this one deserves like its own name. We'll call it, we'll put it up higher. Parse expression LHS allocation failure. Something like that. Yeah. To be specific, right? Okay, what is this? This is a allocation. Wait. Oh, no. I know what this is. So we are allocating the post. Oh, no, we're not allocating it here. We are. Oh, no, we are actually. What am I talking about? This is an add expression, yeah. Wait, where's the other allocation? Oh, it's over here. Okay. Duplicate this. Parse expression. Postfix allocation. Postfix allocation failure. Yeah, there you go. You got it. Yep, +1. Good. What is this? Allocate current left expression if necessary. Yeah, we want this. Oh, yes, this is left-hand side allocation failure. Yeah, good. Easy peasy. Let's go to here. Oh yeah, token index. Or even better, we could do that whole thing we do with the token printing. I'm not gonna bother right now. All right, good. print. Right hand side infix operator. Is this an allocation? No, this is a parse. Parse. Just put it right here. Parse expression infix failure. There you go. Yeah, this one's an allocation now. That's one thing I hate about these enums. Everything needs to be prefixed with the same thing. It's like, can't we just have the name? It is what it is, I guess. Infix allocation failure. Parse expression infix. Specifically an allocation. Oh no, wait. This is just the infix one. My bad. Wait, what's going on? Parse expression infix. Why is it? What? I just made one. What are you talking about? Did I destroy it? Oh, I did destroy it. Why did I destroy it? Infix. Yeah, there we go. Let's go down. Infix failure. Okay, there we go. So I wanted, yeah, because we tried to allocate it. And that's a failure there. This is the list. This is left-hand side allocation failure. Yep, that's always the same thing. And I'll give me the source code location, so that's fine. Yep, that's also left-hand side allocation failure. Probably should rethink that whole thing, anyways. To be honest. What is this? So we try to add a oh yeah, this is an allocation failure. Parse expression statement. Allocation failure, yep. Parse expression statement. No expression. Oh, that's actually... I just kind of like that better. Whatever. No semicolon. Yep. Yep. Good. Match failure. Print statement match failure. Yeah. Match failure, no match found. It's potato. It's fine. Token index, pass that in. Okay. Parameter allocation failure, yeah, that's accurate. No name. Parameter, no name, yep. No colon, yep, yeah, that's problematic. Parameter type, yeah, that's problematic, yeah. Parse function. Allocation failure, yep. Yep. No function, token index, yep. Yep, kind of need an identifier for a function. No parameter, yep. Probably need open parentheses, I mean. Invalid parameter. Missing comma or open, yep. Which I need to rethink this. I don't like the scheme. I think I'd rather just allow an Oxford comma. That's fine. Failure. No type. Yep, that is a thing. Come on, you got this. Okay, get rid of this. Okay. Invalid statements. No closed brace. Good. Yep. Match failure for the definition. Some allocation issues. I don't care about these. Yeah. Match failure. Sure. Actually, that's not a match failure. That's just parse definition failure. Period. Okay, good. It took forever, but we got it. Oh, I just realized I don't have the cat on. Hold on. How did I just realize that? I'm kind of tired today. I don't know. All right, let's turn on the VTube Studio. Okay, let's see if is OBS picking it up. There we go. There's the cat. Nice. All right, back to the code. So yeah, let's see what error messages we get this time. Hopefully I didn't break anything. All right, so parse expression 49, parse expression parentheses close, paren not found. So it's in parse expression. Parentheses close, paren not found. For which token? Token index 100? 100? So token index 100 is 42431. 42. Oh, is this one's messed up? Hold up. Oh, did I just write a bad expression? Oh no, that matches there. Hmm. I guess I don't need the delimiters and the error message. Kind of just hurts my eyes. Let's do just this comma this. Yeah, all right, fine. Okay, let's see. So source parser, parse expression statements. No semicolon. No semicolon? Hmm? I wonder if it's like an interaction between the function calls and the parentheses. That might be messing it up. Parse expression statements. Parse statement match failure 76. At 100, huh? 100 was identifier D. Oh, is it because it's expecting a new line here? Did I make a requirement for new lines to be the end of a statement? Why did it expect it at there? Token 100. Wait, let me make this simpler. Even without it, it's not that bad here, but yeah, let's see. So no semicolon at 51. Token 51. What is that? Yeah, apparently it was expecting a how were you expecting a semicolon? Didn't match, function invalid, definition invalid. Yeah, it just prints out the whole stack, I guess. The call stack, but semicolon, huh? Why did you feel like it was a good time to terminate? That's a good question. There must be some logic then that either checks for a new line or checks for something that's not something else. Because I'm assuming then like if I did this, it would work, right? Yeah, it works fine. Yeah, that's what I thought. So, and I'm assuming if I added an extra parentheses, that would break it. Yeah, good, it breaks it. That's what I want. Error message is a little cryptic, but okay. So that means it returns successfully, but then expects Wait a second. Is it seeing like a new line character or something in the token list? No way. Yeah, no, I don't have white space characters, I erase those. And everything here is contiguous. I know there's new lines, so I was just thinking I stored those out of band. So yeah, because I'm just kind of puzzled on why it just decides to stop at the new line. I don't see any reason why it would. Let's go look at this parse expression again. Maybe it's a good time to like break up that function into multiple functions. Yeah, that might be a good idea, honestly. There's gonna be a little bit of complexity with that, but it might be worth it. So yeah, let's see. Look for left-hand operand, and then check for the delimiters. These ones. So I guess I'm just wondering, why was it cool? Like, maybe it just didn't find a function. It didn't find an argument list, or no, sorry. It didn't find a function. It didn't find a postfix operation. It didn't find an infix operation. So then it just said, like, F it. And then it broke and just returned. But what did it find? Is my question. Because the next valid index was D, which is still a valid token. So why is it deciding to stop there? Yeah, I guess it's kind of hard to reason about the control flow of this when everything's bunched up into these functions like this. Let me clean this up real quick. Okay, there we go. That's a lot easier to read. Yeah, probably should just turn those into functions. I'll get to that. There's just one issue with that, is that like this and this I think need to be like passed along with the function call or something, or maybe some context thing needs to be made for the expression. It just seems like a weird hack. I don't like that. So I'll think if I think of a good solution to that. I think the music stopped. Let's see. We'll play this one. Yeah, I go with that. Where did my chat go? Let's see. Yo, Diesel, was good? What's good with you? I'm chilling. Dealing with some bugs, you know. So a little like, what the hell's going on? But I turned on this music. It's loud as hell. Turn this down. There we go. But yeah, I'm just working on this compiler. Trying to get the parsing working correctly. I got like the expression parsing working. I'm just dealing with a bug in the expression parser right now. To be specific, if I separate, like, so I have this like expression right here, When I have it in separate statements, it's fine. But then for some reason, when I like separate it like this with a new line character, it doesn't want to like wrap around to the next statement. Even though I'm pretty sure in my logic, there's nothing stopping it from doing that. So I'm just kind of confused. Yeah, I don't know. But yeah, feel free to chill if you have any questions or anything. Just let me know. I don't know if like you're working on your own projects or whatever, or you're just chilling. Yeah, just feel free to vibe. Let me fix this real quick. My mic stand, there we go. But yeah, this one, if I clear and rerun it, yeah, the parser is working. But then when I get rid of this, this returns me a bunch of error codes. So yeah, I don't know. I'm working on learning C and just chilling. Oh, okay, for sure. Yeah, I mostly code in like C++, but I'm writing this parser in C, so I'm kind of learning along with you. It's not too bad though, so far. But yeah, why? Okay, wait. If I look at the control flow of this, right, like it's got else. The only two times where it should feel comfortable returning is either like an error code or it just being routed to this end statement right here. I think this is the only place where parse expression success is available. Yeah, these all just say not equal to. Yeah, these just return like error conditions. But when I look at the parse statement, there aren't actually any errors in the expression code. So I'm assuming that means that it exited out successfully, but just in the wrong case. So none of these error conditions got called. Yeah, it just broke somewhere. I was like, all right. I think the only places where it's allowed to break is here. And where else? I think there's one more break somewhere in here. Break. Oh yeah, that's the only break, yeah. That is the only break. Okay, good. That means it's all funneled into that one location. So maybe I could write some instrumentation code here. Print, or not instrumentation. I don't know what I'm talking about. Just using fancy words for no reason. What should I print here? We'll put like a temporary print statement. We'll say like, yeah, we'll check this. We'll say print, it's not an error, but we'll just use the parse error here. Success, and here. Kind of a misnomer. But who cares, just logging. Alright, so success at 31, 31, 36, 37, 41. Yeah, just moving forward. Then something didn't move forward. Interesting. Oh, there's a move forward bug probably somewhere. $51, huh? Okay, it's either the parentheses code or the function call code. So I'm wondering Okay, I'm kind of wondering something. Maybe if I get rid of this, would that solve it? That might explain it. Okay, still an error, so maybe it's the function call code. We'll comment this out. Try this. Oh, okay. What? Yeah, I gotta remember the only place where it feels comfortable exiting is that break statement. Yeah, I don't. Oh yeah, I don't think it has anything to do with because the last identifier is V, and the next identifier is D, and we're moving through the token list, so the source has nothing to do with this. So why does it feel comfortable just? Okay, wait. Success at 31. Why are we calling it 3 times? I get they were jumping off the stack, but yeah, we look for a current operator. Wait, don't we have an inline return somewhere here? I could have swore. Oh, here's the break. Left binding power. Okay, so there are multiple places to break. Here. And did I not add one to the function call? What? That seems like a bug. Because if you go to this, but then you don't check the binding power, then what are you doing? I don't know if that's what's causing this bug. I don't think so, but that also just doesn't seem right. Yeah, okay. Let's just see what that does. Yeah, it doesn't do anything. Let me see if that actually broke my code though. Or if that is just fine. I don't think it's gonna make actually much of a difference, to be honest. Yeah, it's still fine. I think it just forces the function invocation to participate in the binding rules. That's fine. I think before it was just assuming that function calls had like the lowest precedence, regardless of whatever's going on, which, I mean, technically at this point they do, so yeah, there wouldn't be any difference, but if you did mess with the rules, it wouldn't obey, I think. Okay, here's a question. Is it yeah, here's a question. Let me see. And you know what? I want these to be a separate type of error code too. So let's duplicate this. Prints debug log. Right? We still probably want like the file location. That's always super useful. Message. You just pass it in as a string. Yeah. Yeah, okay. That way I can search for it instead of, and I can leave these ones alone. Where was the only one I added that at? I think it was here. This one's just a bit disingenuous. Alright, let's add a few more of these. So let's figure out every time that it just exits and says, cool, we're done. So exhausted right hand side options, moving, breaking, break. Yeah, sure. All right. And let's find this. We're just gonna tag in like this along with it, and we'll say infix binding power is less than min breaking. All right. Yeah, I just want to know what's causing it to exit out early. Is it just it's not finding anything, or is it breaking early because of the values? Okay, this one's not infix. This one is postfix or suffix. Function binding power. I don't know why I'm doing it in capitals. Okay, let's try that. Kind of forgot how to log for a second. There we go. All right. Oh, okay. It's a lot going on there. So all of the final ones, it looks like these ones look fine, but then the rest of these, it looks like exhausted RHS options. So like we didn't find anything, so we just returned. So I guess that just means like IE, like, yeah, nothing was found. That satisfied either a function working at 52, 54, 57, 56. Why is it calling 57 twice? That's my question. Wait. Oh, no, this was successful. Never mind. So yeah, it terminated at the correct place. Yeah, I guess that's the intended behavior of this. So then what if I try and do this? Wait, am I stupid? I think I'm stupid. Yeah, I am stupid. Okay. Yeah, no, I just realized I was wrong. Yeah, maybe I need to take a break. Yeah, might be a good time for a break. Yep, I just realized I was wrong. Yep. Okay. Let's see if it'll work now. Where is my compiler? Here it is. I got so clear. Basics, expressions. Oh, look at that. It worked. Okay. Yeah, I'm gonna take a second. BRB. I mean, I guess I spent all that time adding all the error messages, so that's good. I mean, I guess it just confirmed to me that like it wasn't some random error. Like everything was working fine. Okay, good. Yeah, there we go. Yeah, it looks fine. I mean, I could probably verify this, but I think I checked in some other examples. It was doing fine. And if anything, if there's some like numerical error with the binding power, I want to address that separately. But so far it's been fine. Look at all that. Oh. Okay, so yeah, we don't need all these things anymore. Let's see. You know what? One thing I want to do real quick. Parse. Debug. There we go. Just to delineate the two. Oh, there we go. Debug these. Okay, cool. Noise. Alright, let's find everything with print debug log. There, right now I can search for these ones and erase them. Debug log, get rid of this. Yeah, get rid of that. Don't need that. And the last. Yep. Don't need that. And just the definition of it. Cool. All right. All right, cool. Expressions are looking good. I'm trying to think, is there anything else I might want for like this visual thing, but I think it's fine. Let's start moving towards like some new stuff. What did I want to do? I added this expressions file. It parses now, so that's good. Let's make sure this part parses too. And then we'll be good. Maybe not this part. Yeah, that should all parse. Let's check this again. Good. Yep. Nice. We have 3 functions. We have function 1. The return type is I32, has 3 parameters, and no body statements. Good. 3 parameters, no body statements, and then 3 parameters and 5 body statements. First one is a binary expression. 4 and 5. Two definitions, 5 statements. Yep. Expression count 68, parameter count 11, argument count 12. That sounds right. Token list looks good. All right, cool. All right. Okay, let's check comments. Clear. Okay, parser of comments, left-hand side, something not found. Let's check it real quick. So we have this comment, we have this one, this comment. Oh yeah, we don't know how to do these yet. Which ones would I expect us to know how to do? Kind of hilarious, actually, none of these. Let's just comment this whole thing out real quick. I can add a return statement pretty easily. All right, let's. In theory, that should pass, and I think. I forget if like the nested ones are allowed or not. I don't know, honestly. Yeah, I think it would end here and actually cause an error because I think it's greedy. Yeah, actually, I think that is an issue. Never mind. Let's just comment these ones out individually. Okay, that should work, I believe. At least from the parsing perspective. Yep, one function, one return value, no parameters, no. Right. Yep, that's all there is. Cool. Name is return type. Is the function identifier useful? Probably. Yeah, I might want to add that too, actually. Think about it. One definition, cool. All right. Let's add in the functions, the function expressions, because we're not storing the token for the function name. It might be useful. Actually, I know that will be useful. Think about it. So let's go to the parser. Not function call. We want a statement function. We'll do token index name. Yeah. Yeah, that should be pretty easy. Just wherever we parse function. We need somewhere we check for function. We check for fn name and this, but don't store it. Yeah, so just store it right here. It's just an identifier, so there's no expression complication or anything like that. Yeah, that should be good. The only other thing is pretty printing. So we print the print function. Let's print the print function name. Come on, AI, you got this. Token type, it should be the same thing. Oh, no, we don't care about token type. We care about, yeah, token list get. I think this returns a token pointer. I think it's useful just to get the token itself, actually. Const token pointer name token. Yeah, print the net level, yeah. Print node name, yeah. Print token. Is that right? Parse result, pass in definition. Wait, what? I don't know. Oh, we just store it directly, actually. What am I talking about? Oh yeah, this isn't even necessary. What am I blabbering on about? We just use the token type for... Wait, is this never used? Okay. Alright, let's print this out again. Okay, there we go. Token name, token 2, sample fn, identifier. Yep, cool. Noise. Okay, so what else? Something new. We got the function identifier. Was there something I was going to do after this? Oh yeah, I was trying to make sure the comments one works. So let's get a return statement working. That's probably one of the easier statements to get working. Do we have a return keyword? Underscore return. Carriage return. Yeah, we got the return keyword. Good. So that means we probably regexed it correctly. Alright, so if we have the token key return, then we just need to look for it as a statement. It is a type of statement, right? Yeah. So that means in the parser, we'll add it to the unions. Let's find statement. Yeah. Okay, there we go. Oh yeah, here's the return statement. Yeah, there's no real point in storing the I mean, maybe there is a point of storing the start index, I don't know. But for now, we'll just return the expression. So yeah, the current one we have is the expression. Our return statement. I guess I could just store it directly. Return statement. expr idx. And then we'll just drop this. I mean, it would have been the same thing anyways, but whatever. All right, so let's go ahead and generate one of these. Should be pretty easy. Let's see. So let's go look for parse expression. It's a declaration, and then we want this. So we'll just put it underneath. Yeah, this should just be dead simple. Parse return statement. This should take in a few things. Yeah, parse result. Results pointer. Yeah, some code generation would be really nice at this point for this. Current token. Or index. Min binding power, I don't think we care about that. Let's see what the AI hooks up. Do I care about checking out the semicolon? Not really. So we'll just remove that part. Um, let's go to this real quick. We'll just yoink this. Results. Lots of results for this, so let's go back here. Push this in. See in here, yeah, I really wish we didn't have to do this enum thing every single time. So annoying. Yeah, that'd be cool if there was like a state, like a function name, colon, error codes. And then you could just return that directly. And then not have to name it in an enum. Especially if you don't ever intend on using it in another context, like super expeditiously. I don't know any words. Parse return statement results. I think we always need this. Parse return statement status. About 90% of these are necessary. Actually, I can just get rid of all these, and we'll just add parse return statement failure. Add a little Oxford comma, why not? Yeah, we want this status. I'll put that before. I don't. Oh, you know what would be useful? Let's make a statement index. Maybe. Actually, what does this returns an expression index, doesn't it? The other one returns an expression index because it is an expression. That kind of makes sense. Parse return statements directly returns a statement. Oh no, we have a parse expression statement function, and then that one I believe checks for the semicolon. Wait, let me check. Parse expression statements. Yeah, we do. And this checks for a semicolon explicitly, right? Yeah, it does. Is it arguable that the semicolon could probably just be checked outside of this? I mean, probably. That might actually be a good point. I don't know. I'll see. Alright, anyways, well. Is this good? Parse. Wait, what is parse expression statement? What does that return? Oh no, it does return a statement index. Okay, perfect. That's what I wanted. So you know what? Let's erase this. AI, you can fuck off for a bit. Parse expression statement. It's gonna look more similar to this than anything. Yeah, because you want to allocate the statement first and then do all the checks so the semicolons can be the same, and then we return it. Yeah. No more statement types to parse. It's not really that. It's more... Yeah, there you go. That's more accurate. Alright, and then instead of expression statements inside of here, Why is it not searching the correct place? Like, it's one thing I don't like about VS Code. VS Code, yeah. Fine, I'll do it I'll do it line by line. And AI, can you leave me alone for a bit? Parse return statement result. Just do it myself. Add statement. That's still fine. I'll call it allocate return statements. Or return statements alloc. Sure. Yeah, you can go ahead and statement index. Is that what I called it? Oh, yeah. That's a good point. Yeah. Not equal to add statement depth, then yeah. Parse return statement allocation failure. No expression. Yeah, those are parse return statement allocation failure. I want to check for those cases. Return statement no expression. What are you talking about? Parse return. Yeah. Oh yeah, just do it. You got it. Return statement no expression with the current index. Pop statement. Yeah, you know what? The whole pop and push statement thing, arguably I just want to leave it alone. Actually, I think I'm going to find everywhere where I use this in the code base. And just go ahead and drop these. It's not really necessary to do this. I think the only places I do this is in error cases anyways. Yeah, I have another way of doing this anyways. That's probably better in the long run. Pop expression. Yep, only used there once. Pop definition. Oh, we use this everywhere, don't we? But yeah. I just want to make sure it's only in the error paths. Pop definition. Pop arguments. Yeah. Pop parameter. Yeah, I don't want to maintain any of this. None of this. Okay, so pop underscore. Now it's fine. We have 1, 2, 3, 4, 5. Perfect. All right. Just the definitions. All right. Parse return statements. Okay, so we try to allocate the statement. If it doesn't allocate correctly, we just return. It's fine. If we look for the expression, if we don't find the expression, you just return an error. No expression found. Return index invalid. Yep. What is it? State expression is yeah. So we assign this. We assign the expression index over. We look for a semicolon. Move it forward. We say, yep, successfully parsed it. That's what I wanted to say. And the only other thing is check for return expression. Let's add one more. Check for return keyword. Should be pretty easy. Yeah, that's definitely wrong, but whatever. Yeah, we don't move the index forward here. We do want to move the index forward past this thing. We want not like a generic return statement failure. We want no semicolon and then return statements, no return keyword. Yep. The semicolon's already in there. No return keyword. Okay, it just slipped in the expression thing. Yeah, there we go. That's better. Yeah, there we go. Pass in the index. That should be fine. Current expression. That's good. Okay, so now we want to look for. Let's just look for a particular type, and then we'll say make token type. It's a keyword, and it's not this. It's token key return. I think that's what it is. Check that. Yep, that's right. That's right. That's right. That's right. That's right. Okay, so now we just need to call this. So we should have a parse statement. Yeah, so check for expression. Check for expression statements. Check for I think it makes more sense to do the keyword ones first because those are the simplest to check. So just get those out of the way. Because the expression one takes forever to check. Probably want to do that last. Check for return statements. Oh yeah, this is checking for expressions. Let's put that here. Yeah, we're not worrying about cleanup, so that's good. Parse return statement results. Yeah, return. Rename that. Yeah, this is just a general match failure. That's fine. Parse return statement, pass that in, check for that. If it doesn't equal success, then if successful, yeah, an optional would be amazing here. Okay, so we check for return statements. It's good. Let's see. Uh, yeah, I think maybe moving that semicolon thing down to here might be useful, but I'm gonna wait for a bit because it is some repeated code, but I have this weird feeling. I don't know why. Okay, well, let's just see if we can print this out. So pretty printing, let's go here, print statement. Case statements return. We'll just, sure, I guess. Why not? Print node. Return statement's pretty simple. I mean, either way, we're just printing an expression. But first we want to print return statements. We're moving up index level for some reason. Indent level. This seems weird. I don't know, I guess we'll see how it looks. Is that the distinction? I don't even know. I guess the music stopped. Let's find something else. Let me check if my stream is still good. Switch. Yeah, okay. Twitch is good. And let me check YouTube real quick. Because again, sometimes YouTube just drops off for no reason. Okay, yeah, still good. Cool. Alright. Alright, do I want to have a separate method for this? I don't care, to be honest. Okay, the first thing is this takes in a expression, so we have state, there is no return state, you just type in return index. That's it, yeah. Oh yeah, I suppose just wherever it's gonna be. Print the new line. Is that really how I do it? What if I print the expression? Print expression header. Because this bit is just gonna say, oh, it's a return statement. Print node. Okay, let's just see how this looks, I guess. I don't know, I feel like this is gonna be messed up. I don't know what the AI is doing here. I guess usually I can figure out what I want it to look like when I see it. So let's try it out. We'll go to comments and then add this return statement. Okay, let's pray it doesn't blow up. Did it work? Okay, we did find a return keyword, so it was in the token list. It did get parsed, but wait, is it the only thing in here? I think it is, yeah. Return A. Okay, we have an identifier expression. Wait, is it the whose responsibility is it to move forward? Is it the node itself, or is it the starting body? I think it's the node itself, depending on if the number is injected. That was why we had that. Why is it not printing? That's weird. So I mean, obviously it did parse it, but yeah, what's going on? Oh, wait a second. Did we label it correctly? That's a good question. In the parser, it might have just got labeled as an expression. First statement. Oh, that's a good point. Did I label it correctly? No, it was a statement expression. No, it does check that, yeah. And statements. Out the way. Expression index. Yeah, it doesn't get rewritten or anything. So yeah, yeah. Okay. Do we call break? We do call break. Wait. Print F. We reached the return statement. Yeah. Let's find that out. Oh, it's not even being called. That's interesting. How does that work? Wait, are we unless oh. Yeah, I never fixed that, did I? Ah, let's see. I did clean that up, didn't I? Okay, good. So this directly calls print expression. That's interesting. Yeah, let's see. Okay, so it doesn't return statement, return expression. Yeah, no, that is not what I want. What is print node anyways? Field. Yeah, print node is like a terminal field. The expression. Is that a... Oh, what do you even call that? I think maybe statements deserve their own color. No, maybe. Well, I guess for now I could just give it... Yeah, because these nodes are meant to be like terminal nodes. And then pretty much everything else... Oh, wait, let me fix this. Color. Terminal node. There we go. And that kind of goes with these tokens are kind of their own thing. Argument params, expressions, definitions. Okay, yeah, there we go. So there's kind of a split here. So these ones are the for station colors, and these are specific type colors. Type colors. I guess that's the distinction. I don't know. But yeah, these are distinct terminal node. Yeah, terminal node. Okay, let's find everywhere where we have print node. Print terminal node. Yeah. Yep. Cool. All right, that's more descriptive. So yeah, you wouldn't have a terminal node as like a index in a list. Doesn't make any sense. So yeah, we probably want to have an extra one for definition statement. Define terminal, color, and statement. Let's find some other color we haven't used, I guess. Why are we trying to... yeah, it would be nice to be able to like immediately identify all the statements. That would really help with organization. And yeah, actually having it like directly prepended to the expression would be useful too. We'll just do this for now. Find other color. Let's just do I don't know if full is white. Let's see what it ends up looking like. Let's go ahead and use this. And we want one for, yeah, like expression header and header index. Statement header and statement header index. I could probably do some code duplication stuff with this, but there's only a certain number of these things I'm going to need anyways, so fuck it. Yeah, we have the index, that's fine. Print token. Okay, I think the only place this is really relevant is here. So we'll print statement header. If it's no index, we just do return statement like that. Header index with the list index. There we go. And I think in both cases, yeah, I think we just want to put it in line. I don't know what that's supposed to look like. I guess we'll see. Also, why are we doing the indent before the new line? Shouldn't it be the other way around? Let's just make them the same. Yeah. And then we're putting a new line here. I think the new line probably goes before this. So I'll probably add it up here. Yeah, this just goes directly with return expression. I think it depends on the expression, right? So if it is just like a single line expression, you can just put it there. But if it needs the... Yeah, and then here you just pass along the list index. Oh, no. Wait, never mind. No. It's a invalid list index. My bad. My bad. And then the expression... Yeah, this one chooses whether it wants a new line or not. Yeah, it's better. Okay. And you know what? Let's go ahead and add this. Actually, no, let's not mess with the statement expressions just yet. Let's just see this. Okay, so clear. Yeah, it's white. It's this one. Yeah, it's already placed correctly by this thing. Yeah, I need to find a color for this, but that's actually fine. Because then, like, depending on the expression, it can do different things. Like, if it is some sort of binary expression, I would assume... Like let's add one real quick. Samples... Return A plus B minus C, right? Something like that. Let's go back. Yeah, there we go. Then it chooses to indent itself, which is fine. But yeah, we need a color for statements. Why is it not giving a number? Like this one gives it. Why is the body statement not passing it along? List index. Oh no, if it's equal to list index, then do this. Otherwise, do that. Yeah. Why did it? The hell? Okay, there we go. That's better. Okay, so now we can pretty easily see the statements. That's good. Yeah, okay, I like that. Then do that. And then let's do that for expression statements too. So we'll just yoink this. Yoink. Expression statements. Expression statement. Expression statement. Yeah. All right. Yeah, you don't need all that. Just print expression. Print expression. Okay, now let's try to mess with like the test. Oh, did it just give up? What the hell? Why did you give up? What had happened? Wait, what? No return keyword? No return keyword. Oh, okay, interesting. So the no return keyword. Oh yeah, that's right. I forgot for these things. If it fails. Oh yeah, I forgot I had to deal with that. If it doesn't fail, if it fails, it just needs to like pass it along in certain situations. Yeah, that's right. Like if there's an allocation failure or something, then that's different. But if it's like this type of failure, then yeah, you just pass it along if it's like a linear list. Oh yeah. That's pretty easy though. We just need to filter by the error type at the parse statement. So right here, basically, we just need to check what type of error it was. So instead of this, we're actually going to check for an error case. So we're going to check for if return result.status is equal to parse return Actually, let's go look at the different types. So there's allocation, no express, semicolon. So these three are states that I would have no issue rolling back on. Oh, and you know what? These are actually the specific situations where if we don't generate like say if we generate a bunch of like intermediate expressions but we don't need them, then we might want to have like a rollback mechanism so that we're not wasting memory. Because we need to like kind of like fail soft. Oh, and you know what? I could probably write a pretty easy mechanism for that since I'm just passing the entire storage block everywhere. Nice. Okay. So I think the only error here that is a full-on error is the allocation failure. That one should just abort. But the rest of these are like soft errors in this case. So these three we want to check for. Or what we can do is we can just say, if it's a success, then go ahead and return statement. If it's an allocation failure, then go ahead and report an error, and then otherwise, just go ahead and continue the loop, or continue looking down for more statements. Let me copy these. And you know what? If I was designing like an error, like a first class error system for, yeah, if I was designing like a first class error system for a language, I could see adding a little bit of what is it called? Like categorization to be nice in the situation. Like you could have maybe like a severity level where it's like the first severity level is like, well, if you might have an optional and then return the actual value of their success, and then if there is an error you could indicate whether it's a soft error or it's a hard error, like by the severity value, and then you could filter based on the severity value of the error and then like work accordingly instead of having to check each one individually. And you could do that by just like defining like like an error override or something, or like a I don't know, something like that. I can kind of see it getting a little messy though, so. But ergonomics, man. Parse return statement. Allocation failure. Okay, so we'll say if it's success. For now, since we're working in C, we'll just do this. If it's success, then do this. Else if return status, not this, we want allocation. Parse return statement. If it's an allocation failure, then this needs to be a hard error. Okay, and then we'll erase this for a second. So we have a match failure, parse statement, not no return statement. That's too specific. I want to say this is a successful state. This is a return statement error. Return statement error. Just say error. Keep it simple. And then we can add more to this if we need to. Return statement. Or I could say more like hard error. Hard error occurred during. Yep, that's good. So yeah, we want to propagate. We want to propagate it, or yeah. Check for. Okay, and then in the other category, we just let it fall through. And let it go ahead and pass through. And we want the same thing for the expression as well. So let's see the expression categories. Allocation failure, no expression, no semicolon. So same thing basically. So if it's equal to success, then this, then else if is equal to allocation failure, then hard error, and then we want a parse statement. No, the allocation failure is still a thing. Parse statement. Yeah, person statement error. No, it's not an allocation error. Even though it is an allocation error, it's a parse. I know. Parse statements. Yeah. That type of error is what we're passing back. Else we just go here and then just match failure, and above here we should have oh, there is no allocation error in this case because everything's allocated from here. There we go. Yeah, so we have a case for hard errors to get propagated straight up. We have a case for success to just return it back. And then otherwise, we just move further on until we just don't find a statement anymore. And then that can get handled accordingly. Good, good. All right. So I think that should solve that issue, if I'm not mistaken. Let's see. Or maybe not. I don't know. There's probably something wrong with the printing. But yeah, return statement, and then it hung, so that means something didn't print right. It's looking for a return statement. No return keyword. But in that case though, if it returns no return keyword, because this happened in parse return statement 744, parse return statement no keyword, no keyword. So why is it still being labeled as a return statement? Return results. Next index. Results. Statement index. Oh, yeah, we're forgetting to do this. Is that why? Well, yeah, this is a hard failure state. Yeah, this is a success state, so you want to do that. Oh, you know, one thing too. I need to implement this right now. So since there are some error states that like are kind of fine, in that case, oh yeah, and severity levels for these things would be really helpful too, huh? Yep, see? Let's see. All right. Bro is making a whole programming language while I just finished making a simple calculator with 5 possible expressions. Hey, for sure. Are you following a tutorial or anything? Or like following like any resources for making the calculator? I know sometimes that stuff can get hard if you're depending on how you're parsing the expressions. Oh, okay, for sure. No, but I'm saying like I know the calculator expressions are the same thing, right? You sometimes you need to parse it in a certain way. Yeah, it's basically this actually. How do I? How the hell do I? Okay, wait, real quick. I'm gonna use the restroom. BRB. Okay, I am back. Let's see. Okay, so one thing I think functionally this should work. Uh, Dang, I'm starting to. Bro, I'm running purely on coffee, dude. Whew. Let's see. Okay, let's see. Um, what was the issue I was dealing with? I was trying to figure out. Oh yeah, yeah. Okay, so if I parse a statement, this parsing of the statement could lead to a ton of extra allocations that, how do I say, like, just basically get like wasted, like they just get forgot about, right? Especially when you move on to the next statement, like the next expression. Um, so I need to figure out how to clean that up. Okay, but real quick, let me make sure that it functionally works now. I think I just fixed it, and then I'm gonna deal with that right now. Nope, still broken. What is going on? parse return statement, no return keyword. Okay. No semicolon. 27. Or no semicolon at 40. Wait, what? No semicolon at 40, huh? Wait, am I... Which one am I calling on? Test. Let me see. No semicolon at 40. Oh, yeah, this one is broken. Okay, wait, let me try this. That's actually like successfully broken. Okay, let's try it again. Okay, so that means that it should have returned the correct thing, but why are we trying to print? Why are we trying to print a return statement? It should just be an expression. Hold on. Something's wrong. Something's not being assigned. Something's being like assigned incorrectly. What is going on? We have this token index, right? We do return result next index. Yeah, we do assign it. We return back. Do we do that as well here? Yeah, we do that successfully here as well. Statement index. Return statement index is equal to expression result. Statement index, yeah, that's fine. We're parsing an expression. Okay, I have a question. Is print debug log parsing statement what token are we using at the beginning of these two? Return statement. Expression statements. Wait, how the hell? Okay, so parsing. Yeah, I did not find it. No return keyword, that's fine. And then parsing at the same index. Okay, that's what we want. So 27. Yeah. Yeah, that should be right. Okay, so that means parsing did succeed. We're just not emitting the right thing for some reason. I don't know if it's because in the parse expression statement something's wrong. Yeah, we have the statement expression. It is assigned to that. Is it being overridden or something? That doesn't make any sense. Or in the printing is it being misinterpreted? That's also a fair point. State type statement index. Statement expression. Oh, wait a second. Oh no, I think I understand why. Oh yeah, yeah, no, I think I understand why. It's because yeah, okay. Yeah. I think it's because when we parse a statement. Okay, yeah. So we're in what context do we parse a statement? We parse it in a function right now. Okay. Where's the parse statement call? Yeah. Okay. So what's happening is it's parsing it in a linear line, and then whatever is just the current statement index is what's going to get added. So we generated a statement at the beginning, but then we abandoned it. So that's still what's getting printed, even though it's like a half-baked thing. And that also explains why it's not printing an expression. Is it a compiled language or interpreted? The fact that it's already 1K. Yeah, like the parsers. I want to when I rewrite this, there's a lot I want to clean up. And what is it called? Like, I want to use some sort of like code generation for this part to define the rules. For the parser too. We'll see. But yeah, it's a compiled language. Diesel. Let's see. Parse statement. Okay, so yeah, I understand the issue though. So it's just the fact that I'm basically yeah, like writing in like a statement and then abandoning it for like the soft approach. So I just need something where I can like store the current like memory statistics, and then I can roll back in the case where I don't need that memory anymore, and I can go ahead and just reassign it on the next one, because I have like the success case, I have the hard failure case, and then everything past that to the next one is the soft error case, where like we still want to just check for the next expression. Yeah. I could probably just make some like paired functions to do that along with the storage. Let's see, where's my storage stuff? How's it going, Zaka, then? Chilling. Oh yeah, I forgot. Let me show you like where it's at right now. So I was just working on adding like a return statement, but I got all these expressions working. It's just what is it called? Yeah, now that I added the return statement, it's kind of broken, but I think it's easy to fix. Yeah, we'll just do this. And then when we come in, we get the results. Hard failure still is just a hard failure. Otherwise, yeah, this is the success situation. Yeah, I think a lot of this will be solved with like a defer keyword, an error defer keyword, or something like that, where you have those cases. Yeah, I have a few ideas how to like clean it up. Yeah, I'm not using exceptions, so we're gonna handle the errors directly. I don't mind that. But let me make sure this is still valid. This checks for that. If not, it's a hard error. Otherwise, it's still a hard error because it's a match pass. It's a match failure. But at that point, if it's a match failure, that's just a hard error. I think that's fine. So let's try to run it again on this. There we go. Yeah, well, I got basic expressions. The only types of expressions I can't handle is like ternary. Although I think it's pretty easy to add it from what they said on the parser. But yeah, I got like infix, prefix, postfix, function calls. Um, this is messed up. What is going on here? I'm working on this part right now, so it looks kind of gross, but maybe ignore that. But yeah, it seems like it's working, you know. Yeah, but yeah, right now I think what is it called? Yeah, there's no way to get around like the verbosity in C at the moment. Like having to define like each of these because I kind of want to have like what is it called, like results plus like the types for every single one, just so I can have like an optional situation. Just makes the code like way longer, plus all of like the error checks. Yeah. My brain. Okay, so yeah, let's get this working. So the solution to this shouldn't be too bad. Let's go back to my brain's starting to die. Where was I at? Parse return. Oh no, parse statement. That's what it was. Statement. Postfix plus plus and minus minus are awful when you end up producing a value and returning something. Because when you prefix it, yeah, that's fair. Because every time that I've used the I guess like convention wise, I never put a postfix inside of a expression because I always find that confusing. I mean, I could reason about it, but yeah, it is always confusing. Um, but yeah, it is doing multiple things at one time. It's assigning it and returning a value. Do I want plus plus and minus minus? I do want some element of that because I don't know. It is still like an ergonomics thing. I don't plan on having like operator overloads for that type of thing, just for integers. But I do agree that it is just kind of gross seeing it in the code mixed in with like a bunch of things. Just messes up the control flow. I got you. I got you. Yeah. I'll think about it. I'll think about it. Are there any other postfix like operators that you ever use, like for your language or you've seen? I haven't like looked around or anything. I don't know. I mean, of course, there's like the function. There's the function call syntax, but yeah, I only have binary, unary, and then the urinary is a prefix, right? Hmm. Hmm. Yeah, I guess it's like a style thing. I am basing my language off of like C from the beginning, so I guess it's just like what I'm used to. I'll think about it if I want to move it. I think what I want to do is after I finish like the first pass of the language, I'm gonna take a second and probably try and figure out a way where I can use some sort of like definition that can generate a lot of the compiled code for me for the parser and for the lexer. And that way, like if I want to like, because I kind of want to like define like also maybe something else for maybe when I get into what is it called? Uh, some of the graphics language stuff. Maybe I could make something my own little language for that too. Have something reusable. Lexers are simple enough to write by hand. Mine is 600 lines. Yeah. I remember yours was like pretty terse. Yeah. Yeah. What was it called? I don't know. I'll see. Because I do want to explore like code generation, but just not using macros. I kind of have an idea for it, so I want to try it out too. I feel like there's like, kind of like two camps with the code generation. At least in my mind, it's like either the code generation produces like a final like code file that you don't ever intend on modifying again, like kind of like Glad, you know, or it's like the code generation generates something that you do intend on having different values depending on like the external data, and then in that case you either use like predefined like API functions to access the generated code, or you just access it directly, but at that point you would need to be okay with the repercussions of it just getting messy. You probably just want to reduce that the scope of that if you're doing that too much. I don't know. I just don't want to deal with macros. But yeah, I was just thinking about code generation in general. And I don't want to deal with regex. Let's see. But yeah, I think in the first pass of this, the first thing I'm going to do is just get it done, get it all written out in C, get it to work, and then I'm going to go over this code again, and then I'm just going to try and figure out how I can get like my programming language to just make this whole thing like simpler. Like try and figure out how to like solve a lot of the repetitiveness just using like the language itself. And then like once I've gotten to the point where it's like, okay, I've cleaned it up as much as I could using like my own like programming stuff, language stuff, then I'll explore other stuff and I'll see. Because yeah, I definitely the defer keyword will just be like amazing for solving all these issues just by itself. Yes, I need like a rollback thing. Let's see. So rollback. So what would that look like? Because we have the storage for this. So I'm thinking something where we can capture the state of like the count and the capacity, or just the count, the capacity. Yeah, who cares? Because we're just gonna roll back. So it captures the current state before some sort of function was called, and then after we can capture the state again, and then just check the differences, the difference for each one, and then just pop the differences. So just some methods for that, I guess. Does this need to be exported? I don't think so. I could just do this internally. Where do I have my functions for modifying? It's right here. So I'll define it below these. What's a good name for this? WC3. Is that Warcraft 3? Or is that like a new game? Let's see. I did not. Yeah. I think I started the first Blizzard game I played was like World of Warcraft. Store. So I want something that can store the state of the counts. Probably have some asserts too with it. Are you playing Warcraft 3 or? I do know of the game. Like a rollback. Rollback. Storage. We'll just have one method that rolls back the whole storage. I can separate it later if I need to. I'm an RTS enjoyer. Doing Warcraft 3 campaigns on max difficulty is brutal. They're never this hard. Yeah, I always wanted to what is it called? Hard to find this as like a struct or something. I always wanted to go back and play some of the old school strategy games because I do love those. Or I do love my strategy games. But I think the strategy games that I played were a lot they're definitely like way easier. Like I think the first strategy game I played was what was it? Halo Wars on Xbox. That one was hella easy, but I kept playing it over and over again. And I remember playing a lot of Sid Meier's. A lot of console games back then. Let's not define these individually. Let's do like a struct or something. Struct. So, I mean, yeah, I can show you real quick. So, because before I was going through every single like when you parse an expression, you have to like allocate. You might have to allocate other expressions, and then like it moves forward or whatever. And then like in the middle of it, it might panic and then go back up. It might be an error you have to like roll back for. You might have to like go back up the call stack. Up until this point, all the errors have been like hard errors. So it was just sort of like you just go back up, report it, and call it a day, right? But for like parse statement, the way I'm trying to get it to work right now is what is it called? Like you would parse this one, but the error codes that it returns, like these three are like ones that like we would check if like you would be able to recover from it, right? Like if it didn't find this, you would go back and say, okay, we didn't find one, let's move on to the next one, right? And then what is it? Where is it? This allocation failure is like a hard error, like something happens, so just report it. And then this is like the success, so I mean it's not an error, but like in my other language this would just be an optional, but whatever. So instead of recording each individual one, I'm just going to record the state before I add this thing. I start like before I start doing this, I'm gonna record the state of the storage, and then if I pass through but it was a soft error, then I can roll back on the ones that were allocated. like any expressions, any statements, any whatever that was any difference between these two can get rolled back, and then we can start fresh here. I mean, it's basically like it's because of the way that I'm like storing the statements, because when I go back to parse function or wherever I use this, the way I'm doing it is, let me see if I can find it. Yeah, here we go. So basically, I'm just getting the current index of like the statement in the storage, and then I'm just moving linearly through. And then once I'm done, the statements are literally just from the starting point over to the end point. Like I just record a size and move on. And then this just becomes like start index plus size, right? I mean, I could update this in a way where like, I don't know, like, because I remember for you, the way you do it is you store a vector, and then you allocate it on the heap. Or, I mean, you store a vector, right? And then you wait until it's like a fully valid like thing, and then you create it all at once, and then put it on the put it into your memory, right? Yeah. So like right now I'm not using temporary buffers, so instead I'm just rolling back. But the rollback isn't expensive at all, like, or it shouldn't be, because all it is just moving back a count. But yeah, like I think we're fundamentally doing like two different designs, so. But yeah, collect all things, arena, allocate, slice, pop. Yeah. For me, it's like collect, or what is it, like just start the initial index and then start parsing. Oh wait, parse parameter. Let me find the statement one. Parse statement. Yeah, just start parsing. I don't care like what you end up doing in between here and when we exit. But I just want to know what you actually allocated in between the start and the between the start and the end. And then if it's not necessary anymore, like we're still moving towards like a success state, then just roll back on the ones that you didn't need and then continue. And then the rollback should literally just be like move the count back a few numbers. So it shouldn't be expensive. No. It's like literally required for this to work. because again, like I'm just storing like the starting index here, and the assumption is that this starting index is the actual starting index for like this sort of a range, right? The range being like the start index and the count, right? So we store this current start index, and then we loop through a certain number of statements. Yeah, so it's just going to be a pop, basically. Yeah. So we're basically just storing the starting index, and then yeah, we're just going through here, and it's just to facilitate like a soft like rollback. So a pop, basically. I already have the pops like defined. Yeah, so you just provide a count for each one. So I'm just gonna make like a global one where basically it just records the state before here, and then yeah, like if we are continuing, but it was a soft error in this case, then we're just gonna roll back. But yeah, that way it's like everything still ends up being like linear. And yeah, that's pretty much it. I don't know. I just made it up, so I don't know. I don't know if it's like a good or a bad solution. Let me see. Wait, where was it defining the rollback? Okay, here we go. So yeah, rollback storage. So we basically need a struct for the rollback. So type def struct rollback back context. I don't know what to call this. But it's just gonna be a series of counts. Or maybe like cached storage. I don't know. Whatever. Definition count. And then we'll just have a rollback. And the nice thing is we only have to define it like once in that like thing, I guess. So create rollback context. Does that work? I mean, is it getting the idea? It's basically, it should be dead simple. Just that is equal to storage. Yep. And then rollback should just basically just pop. So pop definition. Yeah. Let me see if that makes sense. So we just, yeah, basically storage. So you gotta be careful about that, but it's fine. There's only 5 of these, so just pop. And is this like, does he yell at me if? Yeah. So if I put it in 0. Yeah. So probably want to do some asserts here. I could also make, I guess if I want to like optimize it or something, I don't know. I could just store 1 on the stack and then just modify it instead of returning it one. I don't know how C behaves with like return optimization. Yeah, you know what? I'm just gonna we'll just do it out. Does it really matter? We just return it. It's fine. So storage minus, yeah. Is it like C assert or something? C assert. What's like the assert library in C, or Google C asserts macro. Oh, it's just assert.h. Okay. Let's see. Storage count is greater than or equal to, yeah, that's what we want. Yeah, if it's equal, it's fine. If it's greater, that's fine. It should handle 0's fine. It should handle more than 0 fine. It shouldn't be less than. Yeah, that would just be an error somewhere. I don't know how that would happen. I think I already removed all the other pop definitions everywhere else, so this should be the only rollback, or the only place where pop happens. Yeah, we'll make a rollback, because a rollback context, like we'll make a pointer for it. Because the only situation we really need this is probably going to be when we do it like in a row a bunch of times. So we just define one like this. Context. No. To add a few more asserts. So roll back. This one's a const since we're not really modifying it or anything. What's wrong with this assert? This person must have a structured unit. Const. It has type. Is it because it's const? So it's doesn't make any sense. What are you talking about? Yeah, I'm gonna assert these things. What? Oh, because there's now a pointer. That's right. Yeah, just do it. I don't know. Okay, so yeah, it's a pointer. We're comparing it to the pointer value. That's fine. I'm gonna pop these. So that's pop those, pop those, pop those, pop those, and then we can move forward. Okay, cool. So then we can just keep doing it in a row. So now it's not stored, it's store roll back context. Okay, easy. Easy peasy. So now that we have that, let's see if that'll fix this. So parse statement. So we'll just define a rollback context. And then just store rollback context. And yeah, just roll back. And then oh, you know what? Actually, oh, nice. So all we really have to do is just roll back in between each one. Nice. We don't, because it's going to be the same. We just create it once up here. Oh yeah, nice. Store rollback. It's kind of a useless comment, isn't it? Maybe something more about the intent of it. Context goes down here. Store initial storage state. To handle soft failures between statement attempts. Attempts. I don't know, that's super verbose, but hopefully that conveys the intent of that. Check for return statement, and then roll back, and then no more types. Okay, cool. Easy as that. Yeah, but yeah, if there's like a hard error, we don't care. And if it's success, then it's success. Cool. Otherwise, we just return back, and that's it. Yep, invalid index. Yep, that's a hard error. Cool. All right, let's see if that fixed that. Hey. Actually, I can't tell if that fixed that or not. Let me see. This is one expression. What was the issue again? It was that I'm like forgetting what I was coding. It was that for some reason with the return statement, it wasn't. Oh yeah, it wasn't pointing to the correct statement, right? But now that we roll back correctly, yeah. No. Yeah, that's right. Okay, cool. Let's make sure this is the right one. So let's try like a bunch of statements now. I don't know. Return 0 plus, yeah, something crazy. Nice. Yeah, I was gonna get a different color, and also this is kind of broken. I was gonna fix that too. Let's get like a specific color for this. And then I don't know what's up with this tab going on here. Yeah, what's up with this tab? Something in the pretty printing. Thing with like the responsibility of the return statement or something. Yeah, I should probably make these into their own methods or refactor some stuff out. I don't really care right now. Print statements. Oh yeah, it's the this one's, oh yeah, I forgot, because it's the expression's responsibility to do that. So if I'm indenting, like this bit is fine. But yeah, I need to pass that responsibility along. Oh, wait. Statement expression, return. With the header. With the regular expression, then we do this. I think in both cases we want the invalid, because this is not what's being enumerated anymore. Vid list index. But that still doesn't explain the issue. I think I need to like look back at this and make sure that the top level, I think right now for some reason like I have like a weird conflation between like the top level handling the spacing and then like the bottom node also handling the spacing. It needs to be like consistent all the way down. That's probably what's happening. Let me see. Okay, yeah, so like this one spaces itself, which is what I kind of want. I want them to space themselves. That's a binary expression. Return statement, and it's this. Oh, is that really the issue? Yes, because that moves itself down. I gotta find another color for this. Okay, now what if I have a, what's another kind of expression? Just like a simple expression. Let's do like ASDF. It's one literal. Doesn't need to be a function. Or not literal. An identifier. Let's see. Where's the return statements? Return statements. There we go. Yeah, so it just inlines it. That's good. That's what I wanted. Okay, cool. Nice. Nice. Yeah, let's get another color for this. White's kind of... What we got? Blue, green, orange. Do brown, I guess. What's another color I haven't done yet? Red. Purple. All major colors. Orange, green. I guess brown I haven't done. I could do pink as well. These are the hex values. Do any of these give me the integer? I want a bright brown. Yeah, let's do this. Do we have a hex to RGB decimal? Really? Picky. Let's do that. Where is 3D printing? The one for statements. Let's try this. Oh, yeah. Good call. All right. Yeah, it's just yellow. Okay. I just want it to be distinct. Give me a distinct color, please. Come on, let's go. Let's do this. Yeah, let's do that. Looks very similar to function. A little bit like a teal. Or like an aquamarine. Yeah, like a teal. Let's do... Man. I can't see. Okay, let's type it over here then. 048C7F. Okay. Hex. Let's leave this here. Hex code to RGB decimal. Okay. Okay, just please be distinct, yeah? Okay, maybe like a brighter version of that, and I'm good. Let's give it like 40, so 44. 80 and 60. Just make it brighter. Yeah, okay, cool. That's distinct, I think. Maybe a little brighter. 80, 220, and 200. Maybe not 2000. 180. Why do I keep doing that? And 207. Okay, cool. Kind of looks like the color from Borderlands. All right, cool. So yeah, I can clearly see statements. Nice. All right, nice. So that was return statements. Good. Let's see. What else did I want to get in? So we can do that now. I guess declarations. Let's get some declarations done. Quick question. How much resources on the computer does C use? I mean, define resources like memory. I don't know. It depends on like. Yeah. What do you mean by resources? CPU usage? It depends on how you write the program. Like, if you write it in a way where like it's like infinitely looping, and there's nothing like it's just continuously working and like looping hard, it's going to use 100% of your CPU or whatever the OS allows it to do. I don't know. I guess it depends on the operating system. We could try it out. 2 nested loops. Yeah, I mean, it would still be doing the same amount of work. Like let me see. Let me see if I can. Yeah, you should see it on your like your task manager. Like it'll be going crazy if you're doing like an unbounded loop and it's never halting. It's gonna work hard. Yeah, it goes crazy. Yeah. Yeah, again, I think the OS like tries not let it take over your entire CPU. Especially if your CPU is like multi-threaded or is like has multiple cores, then yeah, it won't take up the 100%. But I don't know enough about that to like give you like a good answer though. Like a proper answer for the hardware part of it. Let's see. I suppose an assignment operation is just an expression, right? Just with like lower precedence. So there's no need to define that as its own statement. I think in my other language I had it as like its own statement. But I think declarations definitely deserve their own statement. That's a very specific syntax. So let's get those working. So let's get this working first. A is equal to 565. I think currently this is not going to work, but this should be pretty easy to add. So clear samples basic comments. Yeah, it should error out because of return statement 8. Yeah, I couldn't find a return keyword, so I tried parsing expression. At 9, no semicolon. Well, yeah, because it couldn't figure out what this is. I should probably find a way to get better error handling for that, or at least a better message. I just failed to parse, right? Statement. Because I'm assuming it just found a decent statement just with A and then stopped because it couldn't figure out what equals is. It couldn't match it, so it just returned an error. Oh, well, that's good. Yeah. So yeah, this should be a pretty easy fix. All we gotta do is go to tokens. We already should have an assignment operator. Yeah, operator assign. This one. So we'll just add it to the infix. Case toke op assign. Okay, and I forget, does assign have like maybe I can think this through instead of relying on the internet. If it has a lower, let me see. So if the binding power is higher, that means it's gonna attract it more. Okay, so 5 and 4 actually was a good call because I think the equal sign is a lower binding power. That means it'll try to assign it way later. Like the dot operator would be like, you would assume it like binds super close. So the assignment one would try and let everything else evaluate first, and then it would assign. Yeah, and it would definitely be less than minus and plus. So yeah, we have to. That's the other thing. I want to be able to define these numbers and all the other stuff like as data, and then do some code generation to generate the actual code, or generate the actual like final numbers and everything. Because doing this by hand, I feel like is kind of error prone. I guess 5 and 4 is fine right now. It is infix, but no, we want it to be consistent. So you wanted to do one less and then one more. Yeah, because ideally it doesn't really matter. It just binds one way or the other, but you want it to be consistent. I think that's the only change I need to make. Okay, there we go. So, and yeah, let me try and add something complicated to it too real quick. Why is assign an operator even? Is usually a statement. I mean, I don't know, because I remember last time when I wrote a parser, I did make it a statement. I don't know. Is there like a benefit to making a statement right now rather than dealing with it later as just an expression? Because can't you technically chain assignments in other languages? I don't know if that's a good or bad thing. I don't know. Print x is equal to 5. Yeah. Print x is equal to 5. Because I know you can put those types of expressions in what was it? In C, they do that with what is it called? Like conditions. They put like assignments instead of conditions. Yeah, although yeah, every time I have seen that, it is a bit kind of weird, isn't it? For sure. And then I'm assuming like I guess what I'm talking about is like when you have the situation where you have like an if statement. I know you can do like, you can do declarations in here too, right? Like you can do like, I don't know, like let B is I32. Right, and then like whatever that expression is going to be, and then it's like local to that scope. But that's a declaration, not an assignment. An assignment would just return the value to, so you have to explicitly define this to take in an expression or one of the other ones, which is fine, I guess. All expressions should do is produce a value. Oh, like generally speaking, right? Like ideally. Conflating the side effects. Yeah. Sounds very, very functional of you, Zaka. No. Yeah, I mean that's fair. Yeah. I'm I'm trying to think if I ever do that in my normal code, and then do I ever care? I guess the only thing is like keeping those variables scoped to like the local context, right? Like then we have for loops, so that's fine. There was this thing that I remember, like didn't C++ add something where like you can like declare like local scope variables for like a control statement in like a separate block before the body? Isn't that like a thing? I never used it. I was just remembering that you could do that. C++ declare if C++ adds something, it's usually trash. I'm dead. I mean, I don't know. I'm just trying to think it through whether it's what is it, a good or bad feature, like on its own merit. Declare what is it called? Declare scoped variables before block. Is that a thing? Switch with init statement. Summary of scope rules. Blocks and variables declared inside curly braces are only visible from the point declaration until the close brace. I mean, yeah, I get that. Is there variable is in block scope when you want to emphasize that it's really an object that does not block in which they are declared. There's the name of something like counter for loop. And I usually enclose separate tests in a different block scope, so I have to deal with name collisions. Yeah, I know that's the normal way you deal with that. I don't know if I particularly like that. It's like I know when like say you have a series of functions, right? Or no, I mean you have like one function and you have like a series of operations. I know if you really want to make sure that like nothing is leaking between them, you put like this, you know? It's like a general block expression, and then like if you had like a while loop or something, this stuff doesn't leak out to here. But if you have a for loop, you don't really have to worry about that, right? I'm trying to think if there's any other situations that I would care to have that. Hmm. Having assign expressions inside. Will this be open source? For now it's closed source. I mean, again, like I'm just working on the language by myself, so like at the end of the day, like I'm probably the only one who's really going to be using it. That's why I'm kind of just thinking about like things that I care about, you know. But yeah, if I ever get to the point where I feel like, you know, the language is like coming together, I might open source it. But oh, we'll see. We'll see. For now, I want to keep to myself and just kind of like get it formed together, you know. Having assignments. X is equal to 5 is equal to plus plus. Assignment expressions. Hmm. So the language forces you to put these things on different lines. Because again, like I agree with you, like Zaka, like when I do write my code, I never like having I never like having like basically what you put right there, right? Like like this, right? I'd be like, okay, X is equal to 5 or is equal to yeah, see what even what even the hell is this? I wouldn't even bother looking at this. This is so confusing. Like it would be like this, then some other statement, then some other statement, and then each one would have its own clear like operation to result in something. This just seems like up to interpretation. Yeah, so like in practice I never do that. Mm-hmm. Oh well, I mean, I don't know about nobody. I think some people do that, but I don't think it's good practice. mm. If you have a function call, well, you could have methods. I know some languages take it to like the extreme where it's like you either have a procedure or you have a function. Or what are the two what are the two ones that are like separate, but a procedure can only produce side effects, and then right, is that, am I getting that right? I can't remember which one's which. And then you have another one where like the function produces like an input and output, and that would be an expression, right? Yeah. Like I wouldn't go that far. I think functions being able to be like have their side effects, because I feel like if you take that to the extreme, you could say that like if I never wanted to have a function that could lead to side effects in an expression, you could be like that could never be in there, you know. But realistically, like that, you know, probably still want to have that your side effects and stuff in the expression. Yeah, yeah. Although I do feel like having the separate keyword of like procedure versus like a function like is kind of helpful, I don't think I'm gonna do it in my language. Like I kind of like I saw that and I was like, nah. But it is nice to like see at a glance that the only purpose of this function is to like produce side effects, and the only purpose of this other function is to input and output. Oh, it's called function coloring. Oh, why is it bad? I've heard that term though. Function coloring. Oh, is function color just like delineating between different types of functions? Splitting functions of different types and then having rules with restrict usage. Mm-hmm. To get it to work, right? Yeah. Hmm. That happens with async and Rust. Yeah, I saw that Rust has like some kinds of like decorators for certain things, but async where you must make everything async is what is that? What is that model for async? Is it similar to like C sharp, like the syntax at least in Rust? Yeah, they do have the like async and await. It's like a C sharp thing, right? Or like originally. I know JavaScript has that. So I'm assuming the reason why you don't want function coloring is because it boxes you into like one camp or the other, and then if you need to reuse the code, um, it's basically gonna be like code duplication, right? In like a different context, or you have to like go in and modify it, and then that messes with stuff. Yeah. Hmm. Hmm. But aren't I mean, I haven't done much like async and await code. Like I'm used to C++ async, so I have no clue. But like are async methods aren't they like pretty distinct from regular methods, or like would you have cases where you might want to reuse the code between the two? Because don't they have their own like distinct keywords and stuff? Kind of like how like a coroutine method would have distinct like control, like valid like control statements. No, I got you. Yeah. I mean, but I'm just wondering, like, is that particular instance of like coloring like super bad? Like, have you ever dealt with that kind of thing? A generic parameter. Okay, okay. Hmm. In Rust or like in general? Like it's just like a proposed idea. I'm assuming it's already kind of like hard coded into Rust. Oh, sure. Hmm. Yeah, I wonder like if um, yeah, I do feel that like that function like the coloring thing or like adding or maybe not specifically function coloring but just adding too much stuff at declaration time like for like I think I feel pretty strongly about the fact that what is it called um where is it for like my structs and whatnot. I don't really. I'm probably gonna drop the config and manage. I'm gonna see. I gotta make sure if it's actually gonna be semantically like do anything actually, or if it's not. I'll see. But other than that, I don't think I want any other decoration surrounding a struct. You know, like anything that you add to the struct should be later down the code base. Kind of like just overriding it or whatever. So like no member functions, no like yeah, any other decorations. Maybe like uh maybe like access specifiers for like packages. Just to say like by default it'll be like file local and then like you could make it like part of like the public API or whatever. I haven't looked that strongly into it, but I think that's the only thing I might put on it. But even then I'm like maybe you could make that separate. I don't know if that's confusing or not. Yeah, I don't know. Oh yeah, we were talking about whether the assign should be a for sure. Mm. So you could put some expression before the assign block, and then put some expression after the assign block, right? And then the expression before the assign block needs to be some sort of like L value or just some value that can be mutated at that scope, right? So I know L value is like a C++ term or whatever. A variable like X loads from memory. Using a variable like X loads from memory. Yeah. I'm also kind of wondering like just as a separate thing. I think I agree with you, right? Like as far as like allowing arbitrary assignment operators in just expression code. Now one thing I'm wondering though is like is it worth it to split it out right now at the parser level, or is it more worth it to just do some checking on it at the semantic or like a later stage? Like just let it be a expression and then check it later. So what's the benefits of that? You don't parse functions into expressions. You don't parse functions into expressions, right? So same idea here. Put things into correct headers right away. I got you. Then there's no possible way that you would have an assignment in some like random place where it's not really meant to be. Like you could say like in like a for loop, I'm only going to allow this type of statement, this type of statement, and this type of statement. And you can be more specific. Or yeah, it'd just be easier to deal with because I guess later I have to check every single one for. That one is the operator, then it checks for that one. And I guess it wouldn't be any different than doing the other one. I'm just trying to remember too, because last time I wrote a parser, I immediately put assignment as like a statement, and I was just trying to remember if that made it like complicated. But it's just you just check for an expression. You check for an assignment operator, and you check for an expression. And then you can do the semantic analysis later. Yeah. And then you would just put the regular expression lower down in the priority. So you would check for the assignment one first, and then if you don't find that, then you just go for the assignment. Go for the expression by itself. All right, sure, yeah, that's fair. And then that way it can't just be arbitrarily around in the code. If you do the prefix one, then it's plus plus. Yeah, and then if I allow the postfix incrementer should be there. Do you allow the prefix incrementer to be there, or you said you just do plus equals, right? If you have statements that are expressions alone, then equals is optional continuation into assignment. Okay. As assignment statements. Oh, okay. And then you always have this like those types of statements like yeah, they're statements, so they're on their own. Yeah, so yeah, because they're statements. Yeah, because the side effect is that we're modifying that. So it's clear that we're just doing this operation just for the side effect. For mutating and returning a value doesn't make sense, and it complicates reader/codegen. Oh yeah, that's fair. Yeah, having an expression that just no, I got you. Or at least in the base syntax. That's fair. Do you do operator overloading in your language, or do you not bother? I know. Right now we're just looking at primitives, or in this one. What about for like? I know Odin does that thing where it defines like arrays, and then the operator overloading applies to like arrays if it's like in the type. Yeah, yeah. So like if you have a type, but it's basically just like an alias around like an array, would the operator overload still work in that case for you? Like, as long as like the underlying types match. Like, say if you had like, um, using some different struct type for do 2 F32s for 3 vector types. Hmm. Hmm. I got you. I got you. Yeah, yeah. You just for sure. Okay, so yeah, that sounds similar to for sure. Then you don't have to define any operator overloads. It just works. Yeah, yeah. Same idea as Odin, basically. Yeah. Yeah, I saw that when I was looking at Odin. I was like, that's a pretty cool idea. I mean, of course, it doesn't catch every single case, but it's like most cases it handles. Yeah, and it's definitely better than having like plus equals heap allocate. That's crazy. Yeah, yeah. I mean, I remember. Uh, didn't the guy say he was like a physics major, or like he was like a physics person, and he started writing code? Yeah, and built in complex numbers too. Yeah, yeah. Okay. Yeah, yeah, that's fair. Wait. So what was the thing you were saying for the assignment operator? Let me go back down or back up. If you have statements which are X per alone, then equal is optional continuation into assignment. So basically, like you check for the expression. Okay. I think I get what you're saying. It's kind of like how when you do like the NFAs or the DFAs for like the finite automata, and then like you kind of combine the first state, and then it diverges into like either the null or the other state. So it's either if you can go over to the other one, then get that one. If you can't, just leave it where it is. That's fair. He said that's too much. I mean, I guess if you need it, I don't know. Maybe he needed it. He was like, "F it, throw it in there." Okay, for sure. Well then, I will not put the assignment as a random literal. And then I think for postfix, I don't know if I'll ever use a postfix. I'll leave it the way it is for now. Like, how do I say? Where is the thing? Token. Or when I say leave it the way it is, I mean like I'm just gonna return. Basically, just comment this out. Or maybe I'll just do this. I might come back though, because I never know. But just return a failure. And keep pushing. I don't want to pull out the code that I already put in. Um, I think I'll do like a final pass when I come back. After like getting it end to end working. And then for the prefix, yeah. Where was the other one? They're saying. Wait, like, so you don't mess with like functional languages, like in general, or like the idea of like functional languages? Okay. I've been meaning to like, because I keep trying to like read into functional languages and try to understand them, but I get some of the principles, but I still feel a little bit like, I don't know, you know? Yeah, yeah, that's fair. I do feel like the ability to like completely discern whether like a function is like a pure function versus like something that has side effects, I feel like is pretty useful though. I don't know about forcing you to make a decision in the actual code base, but like I feel like being able to like have that knowledge is kind of useful. Yeah, I don't know. What was I gonna move? Um. Oh yeah, and then if, for the plus equals and the all of those operators, the minus equals, if they're not part of the regular expressions, then it'll stop there, and then that'll be a good point where you can like continue it. Okay, yeah, that's fair. Oh yeah, let me go to the infix operator. So let's get rid of this. So let's add the statement type. Statements. There we go. Declaration. Wait, do I call it assignment or do I call it? Yeah, assignment, right? That makes sense, yeah. I mean, I might have some extra stuff it does to it, but the core is assigning it. And then we might want information on all three since they might have different things. So took index assign just operator. Expression index. Let's put this for now. Left hand side expression. There's no statements for it, just an assignment. And then in this case, a declaration might also have like some extra what are they called, like decorators, but I'll leave this alone for a second. Yeah, so this must give a name, so we'll just call it name. The type, I might expand it to an expression later, but we'll just do token index for now. Let that a is equal to do you make a distinction between a declaration and a declaration assignment, or are they just the same for you? Expression. Variable declaration is separate. Like so you would have like a third one here that's like wait. Var decal has name on the left, not an expression. Totally different. Oh wait, I wasn't really looking at these. I'm gonna comment them out for a second, but let me see what you're saying. Var decal is separate, of course. Oh, var variable declaration is separate, of course. Variable declaration has name on the left, not an expression. Variable declaration has yeah. Variable declaration has a name. Yeah. So let name is equal to expression. So what about like let name and then you don't assign it to anything? Would you make a distinction between that and the one that where you do an assignment at the same time? Like let name is equal to exper versus let name. Oh, okay. So you would stick it in. Yeah, I think that's what I was asking. Like, whether you would have this and like a declaration underscore assign was like two different things. Okay. So that means token index is a name. The type is, we'll just put like a name for now. And then whatever we're assigning it to, it's gonna be expression. And then maybe like a Boolean or is that like a good thing to enforce? Like always require you to initialize it, something? I know like Zig requires, does Zig require you to like assign it to like undefined? Was that right? Like a keyword? And then like if you're not gonna assign to anything? I think I saw that or something. Like it requires you to sign it. Is there use just declaring things? Yeah. I think I saw Zig does some. I don't know if it's the same keywords, but it's something like that. Zig initial declaration or declaration. I just kind of want to see. Yeah, I mean, I kind of prefer the explicit syntax. I'm just trying to think of a case where like, plus I feel like having like a specific undefined keyword is like kind of like, it's like, okay, like it's very easy to see that you left some memory as like undefined when you started, right? Versus like it being zeroed out. Yeah, you can search for it. I think I like just like that better, yeah. Like just searching for a non-zeroed variable, or like just searching for it without the declaration or any like assignment attached to it. Yeah, that's just annoying. Yeah, I think we're just gonna enforce that it always is assigned to something at least. I think that's good. Yeah. Okay. So we'll do that. That's good. I'm like trying to think like yeah. No, that's good. That's good. I like that. Right, right. Let's see. So type. Okay, so let's get one of these. Let's get the assignment working first. Mm, is it worth it to put the assignment ones into their own? They're just operators. It's fine. I'll just make a thing for it. Where do we start? So our statement. Okay. Later, Diesel. Hope you have a good day or night, whatever time it is for you right now. Thanks for hanging out, man. I hope you got a lot of progress done with your C code. Yeah, we rolled back. Yeah, how many hours have I been streaming? Like, oh, like 5 hours. Okay, I thought it was more. So I remember you said you use tagged unions for this, Zaka. Let me see. Tagged union for parser. I mean, I know what a tagged union is in general, but you're cool for defining like a struct which allocates space for each field. A tagged union overlap storage. It's okay. Well then, yeah, I mean that's pretty much what I have then. Mm, mm, yeah, fair. Yeah, I kind of forgot I had tagged unions, but I remembered. Yeah, I do. They're just like C style. Yeah, brain is dying, man. Um, okay, let me see if I can power through this. I feel like my brain's like not letting me think. I gotta force it though. Parse statements. So parse expression statement. Mm, yeah, so you parse the expression statement. Oh yeah. So that means I could probably pull the I could probably pull the check for the semicolon out of like each individual call and just do that separately. It's probably a good idea. Mm, I'm just thinking like if I am because currently I have it where like each statement is completely independent, but if they are dependent on each other, where one expression leads to another one, then like how do I structure that? Yeah, yeah. It's just like you can just fuck all and do whatever with it, right? Here we checked at the level where you parse a block list of statements. Oh, okay. Wait, a block. But like at the parser level, right? We're just doing it um, do you mean like? Wait, let me see if I can search like at the parse statement, like method, or do you mean like outside of this? When you parse a block. Oh, okay. Wait. So like literally when you're checking at the parse function level. I don't have a specific parse block method yet. Right now, the only place I have it is directly in the function call. Yeah, I don't have a parse block method. It's the code for it's just directly in the function call. That's all I got right now. Haven't had to abstract it yet. Oh, like how like verbose like it looks. Yeah. Get instant index. Our statements. Open index. Wait. But you were saying you checked the semicolons at this level. So like, how would you go about that? At the block level? Interesting. Like I get checking it like not at each expression, you know, like check the semicolon, like check it like outside of like each individual expression. Like check it at the end, right? Hmm. Go here and then I'm trying to think. Because if I do it here, okay, wait, yeah. I got you. Okay, so check for one of these, and then here you check for it right here. Yeah, because we're not storing the semicolon or anything. We're just moving past it. Oh yeah. Parse return statement. Okay, so instead of doing this, we pull this out. Yeah, it's like way better. And then we can just yoink that. Yeah, yeah, like it's like a common thing. Like every statement requires a semicolon. So, oh yeah, true. Because if I wanted to use these statements inside of some other context, um, then it would be annoying. Yeah, some don't. Yeah, okay, okay. Yeah. I got you. I got you. Oh, okay, yeah. Yeah, sorry, my brain's like it's just slow right now. But even just from like a code reusability standpoint, like it's just better anyways. Yeah, we don't even need to go through either. Yeah, no, yeah, it would be at the block level. Yeah. Semicolon. Okay, let's copy this over though. Hmm. Yeah, I need to make a separate function for parsing blocks. So if then that one, we don't want to do this quite yet. Next one, I'm gonna check it here. Okay. Token index. That's what we report. So we successfully got a statement, but then it didn't have a semicolon. So, and yeah, it might be useful to pull that into its own function because you might have other statement blocks that are not. I mean, yeah, we'll definitely have more statement blocks that are not associated with a function. So let's do that. Yeah, copying and pasting all this enum code is so annoying. Parse block result. And then it's going to be a. Is there any other data I need to store other than the list of statements? Not really. So, statement range block statements. That's it. Yeah. Erase all of these. And just say parse block success block no semicolon or close brace. No, just parse block no yeah, open brace parse block no close brace. And I don't know if it's invalid allocation or what it's going to be called. We'll see. Token index, we want the status, yeah. The error operator, and then return type, open brace, look for statements in body. So store these. function body statements equal to body statements. Yeah, we'll leave this one here. And then there we go. Parse block. Parse block. Let's paste that. All right, so return statements. Get current statement index. Then we'll filter token list. So let's get that stuff. Statement range. We don't need this. We can just get the return value. So we'll go results. We don't need that. Yeah, result dot statements. There we go. Oh yeah, we want the opening and closing curly braces too. We'll just associate them for now. It's fine. So open and closing curly brace. Parse block. All right. Paste that. Throw these out. Okay. And then the opening curly braces can go away. So parse function, open brace, close brace, invalid statement. Return type arrow, close parentheses, open parentheses, name, function, name. Yeah, and then I can have one that just checks for, well, let's not, let me not over. What is it called? Over refactor all at once. Let's see. I do have a separate one for checking for argument lists, so I can make one for parameter lists, but I'll come back to it. For error operator, return value. Okay. Parse block. What do I expect from this? Yeah, something like that. That's what I want. Yep. Yeah. Yep. And then return. Good. No, that goes last, yeah. First block, token index, nuts. That is a, yeah, we're already kind of committed at this point, so parse block is hard failure. Propagate. Did I spell that wrong? Yep. Yep. Index return result. Yep. Okay. Check for motion body block. Yep. Yeah, just get an error there. Good. Okay, so let's fix this up. So this one is going to be, yeah, there you go. It's not parse functions, parse block. Parse block. No open brace. There you go. Check for open brace limiter. Increment forward. Oh yeah, for each one we want to check the semicolon, so parse block. Expression statement, also what the hell? Statement. No semicolon. Okay. Token index, yep. None of that. It's just the return value, so we don't need that. Okay, we use that. It's good. I don't know if that's a good delimiter thing anyways. I guess we'll see. Result. Token index. Good. Hard failure. Yeah, it's a hard failure, yeah. Check for semicolon. Yeah, it's a hard failure because you parse something and then couldn't. It's kind of the expectation that we find a statement here. Well, yeah, because we're checking for a close brace. That's the only other condition where that would happen. So no, that's, yeah, that's fine. Well, that's good. And then all the brace stuff is all local to here too. That's good. All right, let me reread this again to make sure. Parse block, parse block, parse block, parse block. Yeah, invalid statements. Is there? Oh yeah, we have the invalid statement one too. Good. Yeah, that just means there was like a hard error or something. Yeah, we move the token index further. And then move it up one. And then we increment the... It's way too much. I don't think a comment. I think we get it. Yeah, that's fine. Be self-explanatory, I think. Why is this? Return failure results with current token index. Invalid statements. Is hard error. Propagate. Somebody is hard error. Propagate. Sure, whatever. I don't care. So check for opening curly thing, results, move forward. Yep. This one back, that, forward. Check for semicolon. I guess these go together. Sure. Okay, I think that's good. Let me make sure the logic here still holds. Yeah, we check here, check here, check here, check here. Roll back, if not. And then return. All right, let's see if it still works. Okay, probably not all this. This is the test. It is the test. Parsing return statement, no return keyword. Parsing expression. Let's see. AI is the ultimate helper class, bro. I don't know why people are so against it. I mean, I feel like there's a lot of, you know, what is the word? A lot of worry about, like, you know, where it's gonna go. Is it gonna take everyone's job? I don't know. Also, I feel like there is an argument for if you overuse it and you don't understand what's going on, you can your problem-solving skills start to degrade. But I do feel like it's a good tool, though. It does help me with my typing. I'm not gonna lie. Do you use AI a lot in your workflows, Michael? Parse function block. Parse failure. Parse definition. Match failure. Okay, what the hell happened here? Parse expression. No semicolon. Wait, did I admit a semicolon or something? What? Okay, that's crazy. Let's try something simpler. Do like A plus B. Maybe we can figure out what's going on. Oh. Infinite loop. That's great. Parsing expression, parse return statement. Oh. No, that's not what you want to see. I did something dumb, didn't I? Let's see. Something doesn't have like a valid end case or something. Start rollback, parse statement. Oh, it's probably because something's not moving the token index forward somewhere. I'm guessing that's the issue. Yeah, I've always been able to program Java from scratch though, so I just kind of explain each method of detail and it understands. Yeah, I mean, I guess the main thing, as long as like you understand, like, you know, I mean, I guess you have the advantage because you've always been able to program it. So I guess it's more for people who just like are trying to learn and are like new to the stuff and they overuse it. I guess that's the concern nowadays. Oh, you use Java, okay. Oh, do you think it's a bot, Zaka? What's the tell? What's the tell, Zaka? I should put my operators there. Oh, I thought you were saying Michael was a bot. I'm like, what? Yeah, I thought you were saying Michael was a bot. I'm like, what? Oh, okay, I got you. I mean, like, to give it more context, right? Yeah, maybe I should put like a background on the chat so it's a little easier. Is it okay to see Zaka, like from the stream chat on the screen? I don't know. Wait, what the hell is causing the infinite loop? That's gross. Let's see. Parse statements. Yeah, I was thinking too, like a dark gradient in the background. Yeah. Yeah, maybe. Probably a gradient though, so you can see behind it. I wonder what part of the visual real estate's the least important. The top right seems okay. I mean, even with that, I still have the zoom where... Oh no. I still have the zoom. It takes all the stuff off the screen, so if I want to like showcase something, you can still just see it. Yeah, it works fine. Java and C are so similar, it's easy to read. It's just more memory focused, right? Like, what do you mean, like memory focused? Like the runtime of it, or like, yeah, what do you mean? I feel like I'm trying to understand this, but my brain is just not letting me. I gotta get this code bootstrapped, man. I gotta get it bootstrapped. Yeah, maybe I don't need to parse every single little feature of this language. Yeah, I might try the pointers in slices too, Zaka, once I get to bootstrapping. I just gotta make sure that I can like write it on top of malloc or write it on top of some something where I can get some pointer stability. Java and C are so similar. These read just more memory. Oh, like you're saying, like C, like you have to do more like manual memory management. Is what you're saying? To manually designate variables to memory or something. Yeah, I mean Java, yeah, like it has a lot of like automatic routines for things. Yeah. C is a lot. I mean, yeah. C is very bare bones, you know. Oh wait, did I get a like a text or something? Let me see. That's nothing. I mean, yeah. I mean, anything you can mess with, anything where you can mess with raw pointers is already like, you know. Okay, wait. Let me lock in for a second. I do want to at least finish this bug before I conk out. Just gave myself a bug. Let's do parse body. Parse body. Wait a second. Did I properly set up the parse function? Token index. We did, yeah, we did update it. And we did parse it. And we did propagate the errors. So alright, I'll let you focus. I love the videos though. Keep up the great work. Oh, okay, appreciate it, man. Yeah. I haven't posted a video in a while. Or like a proper video in a while. But I hope to get back to it, you know. I want to make a video discussing like this language. But I just need to get it to like a somewhat working state first. But yeah, I appreciate it, man. Parse block. Okay, so it's probably in here somewhere, right? Yeah, but it still teaches me a lot, and they're long. Yeah, I feel like if anything, it's Zaka and What's Up teaching. But no, I feel you. For sure. They are the true gurus. The most helpful thing is to switch to malloc for nodes and have a simpler error management. Just check if errors goes up else, but C++ doesn't have anything else, or you can do exceptions. Right. Yeah, I'm not doing exceptions. Yeah, I want to design some type of like error system. I don't know like what I want it to look like, you know. I think I need to like look at some other languages and figure it out. But yeah, I guess we'll see. But yeah, I think having some way of having like stable pointers in general is going to be useful at the beginning, like period, you know. So yeah, just writing it with malloc, probably the easiest way to get it working. Yeah, it's very specific, yeah, right. It's like this, that, this, and like the fact that it's in C is just making it so much more like verbose. Just have to like prepend everything because of like naming conflicts, right? Okay, wait, let me look at the error messages again. So it's getting stuck at 27. Why? I'm pretty sure it, yeah, it just kept doing that. I don't even know what 27 is. Token 27. Do a test. All right, so if I get rid of all this, and let's simplify this a lot. We'll just do A. Actually, we don't even need arguments. Actually, just do this. I'm saying that errors during parsing are simple. 95 times it's unexpected token. Sometimes you need ones like expected statements where you match and didn't find a valid beginning of something. You need something like expected statement or you need to match where you matched and didn't find a valid. Yeah, but it's usually like, oh, it's this is the exact error. Like we just didn't find it, and then you go deal with it, right? Not like some weird like long thing. And yeah, to be fair, the fact that I have to handle allocation errors every single time, or potential allocation errors, is adding more overhead. I mean, allocation errors can happen though, like on any system though. I don't know. Okay, wait, let me run it again. Let me see. Yeah, just get through it, yeah. I mean, I'm just being this specific so that, like, I can handle these bugs that I keep creating for myself. Parse return statement at token 8. Okay, let's see. So token 8, what is this? 1, 2, 3, 4, 5, 6, 7, 8. So we are at the right spot. We're just not moving forward, I guess. Oh, I got what you're saying. Yeah. Oh, like I could kind of combine it into. Oh yeah, that's a fair point. Yeah. Fair point. It's kind of like how I mean, I know this is sort of like a separate argument. Like you could just have like one enum at the top, and then it has all of like the, you know, like somewhat what is the word, like more general types of errors, and then you can kind of like reuse them throughout the thing. And they don't need to be that specific. Is what you're saying? I got you. Oh yeah. I mean, I assume once I start like looking at like the front face of the compiler and like what error messages it does generate. Yeah, I just don't know exactly what that's gonna look like, you know, just yet. But yeah, I'm pretty sure that it should be pretty chill for the parser. I don't know how it's gonna be for the type analysis and all the what is that? Did you get into what do they call symbol tables and everything? I was looking into that. I saw some people use like was it like stack of like hash maps? That was like the common thing I saw on Wikipedia. Yeah, with all the state combinations, it's just have like the ones for like common ones, yeah. Yeah. Wait, where is the? Let me see. But yeah, that's a fair point, Saka. Yeah. I mean, I'm already in it with every system where it's like it's already this verbose, right? But when I come back and bootstrap the stuff, yeah, I probably will. What do you think of like error sets in like Zig and stuff, or just error sets in general? Because I know that's sort of like composing those types of like things together. You think it's kind of useless, or is it? Wait, what was the error again? It was that no return keyword. Okay, so we're parsing a return statement, no return keyword. 8. Parsing expression. So we do move to the expression after. And then we start parsing, and then there's a no return keyword. Okay, and then we're just not moving forward. Why are we not moving forward? I feel like that's like very obvious. This is probably like a very obvious thing I'm not doing then. And it's definitely in this loop. So starting index, token index is equal to next index. Probably the type of errors that I'm returning. You mean automatic enums made by the compiler for error combinations? Is that what I mean? Automatic enums made by compiler for error combinations. I guess I was just talking about like ones where you could compose it for like I know in like Zig they have like what is it? Like you could just have like an error, and then like you can have like the list of errors, and then like when you have like another error, and then like it's just another set of like, you know, other ones, and then like when you return from some like type of like a return value, it could be like either the error set A or like B. Well, they don't have like an or thing. I could have swear you could like oh yeah, it is kind of automagic in Zig, huh? Am I thinking of another language then? Yeah, because yeah, that's right. Zig. I know you can define your errors in Zig like explicitly, but then yeah, the propagate thing, like the thing yells at you and tells you which error sets are viable at that point because they are propagated. I must be thinking of something else then, some other language. I don't know. So is the one in Rust pretty simple, the error system? Because I feel like I heard that the error system in Rust is either like complicated or really simple. And I didn't look that far into it, so I don't know. Wait, so we are finding a semicolon? I'm so confused by this. Wait, let me just do some print statements real quick. Print debug log parsed statement. And then it'll give that. No. AI, fuck off. I don't want this. And then we want this like before here, right? Parsed semicolon for a statement. Okay. And wait. So start parsing statements. Oh. Yeah, I guess we already have this. It's fine. And then we're printing for the expression statement. Print parse failure. So, and then are we, sorry, I'm like trying to check all control paths. I'm like, which one's messing it up? Successfully, I don't know, this is a not successful path. Parsed return statements. And parsed expression statement. Okay, let's try this. Let's see. And it'll stop at some point. Okay, so parsed okay, so it is going through the whole parsing. So parse statement at 8, parse semicolon for statement 11, and then it just goes back to loop again. Why doesn't it ever break out? So that means we are successfully returning the statement. We're getting the correct index for that. I already know like which one this is. This is fine, right? So it's in the block code then. Something's wrong with the block code. Because yeah, it's doing exactly what it's supposed to do in that statement one. Something's wrong with this loop. So wait, let me look it over again. Parse statement. In this case, we are getting the success. So are we? No, yeah, no. This is valid because it's getting 8. It moves it forward because I saw that it's getting updated. We're moving the token forward. We increment the statements count, and then are we not breaking? Is that way? Because it's valid. And my question is, why is it when it loops, it still gives the same value? Okay, I don't know. Wait. So you were saying earlier, sorry, I got kind of lost in this. The only error system I use Rust, it's just result okay and then error. Yeah, so it's just optional. And there's a dynamic error thing which I never used. Maybe the dynamic error thing is the one that I heard was complicated. That is like a trait object or something. If you have a text range of a token, you can print exactly line column positions with source lines. Oh yeah, no. I do, like I have a table that has that. It's just the infinite loop is obscuring it, but I know which tokens are like messing up. Yeah, it's just something. Wait. Let me see. Yeah, no return keyword. That's perfectly fine. Parsing expression statement. We parsed the expression statement. We returned it. We parsed the statement. Turn that. Parse a semicolon. It's at 11. So then what is happening at the loop? Because like I don't get it, because we're moving the token index forward. So how is it? No, I mean, yeah, that's exactly what I'm thinking about, but like, aren't we moving it forward? Like, why is it looping back and then the token index isn't moving forward? Yeah. That's what this is. That's end of file and closing brace. But what it just seems weird because it's getting stuck. But in the log, it is literally like updating. Like it's saying like parse semicolon parse semicolon for 11, right? Which is this bit, unless I'm mistaken. Parse yeah, it's that one, yeah. So results statement count plus plus. It's 11, then it moves to 12. Wait. So 11, then it moves to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then it moves to 12. Yeah, that should be there. Yeah, I'm doing like one based indexing like when I print it out, so that should be right. Wait. Because we're copying by value here, right? Yeah, we're just copying it over, so that statement count. Let's do a printf here. Wait, printf. Next token index is 12. Delimiter close brace. Wait, so what is it right here? Uh-huh. Wait. Start parse. Finished parsing next token index 12. Start parse statement at 8 again. Wait a second. Oh, wait a second. Are we even in this loop? Finished parsing block statements. Oh, wait. Okay. For some reason, I thought we were in the... Okay. Yeah. Okay. All right, fine. Yeah, I think I've been what is it called? Trying to get away with like what is it? Indexing using copying indexes, but yeah, I'll use speak and consume. I use speak and consume in my Lexer, but for some reason I was like, let me try to do it using copied indexes. But yeah, this literally wouldn't happen if I had peek and consume. So yeah, I think the next thing I'll do is just start using that instead. Because yeah, this is a crazy bug. So what's happening is I guess we're calling this parse block from a parse function. That's what's happening. What is at and eat? Peek, consume, at, and eat. So at is just peek token. Eat is at is just peek. At is just peek is equals token. Eat is if at is if at plus consume. Oh, I got you. If at then consume. Oh, I got you. For sure. Yeah, it's like if at there's a bool and then if eat. But it also like consumes. Okay. I guess I was just hesitant to like add like a... I mean, you can't make member functions in this language anyways, but eat will advance. At doesn't. Yeah, it just checks it, right? For sure. No, I will. Yeah. But yeah, I think it's in here. I think we're here. Function body block. Wait. Print Is it because I didn't do this? Was that why? Okay. Let's see. Passing return from function. Parse block 1. Oh. Oh, the next index is messed up here. I see. Oh yeah, and then I don't have to pass in the I don't have to pass back the next index every single time. It's already in the state. Yeah, I'm gonna use a peak and everything. Also gonna have expected errors. Okay. Yeah. Oh, that's fair. For like different semantics for it. And then oh yeah, and then its name too, so you can kind of. That's cool. Yeah. Yeah, I just realized the issue. It's wait, what? That's crazy. It's literally because of this. Statements. I already updated the statements, I think. Yeah, we update the statements directly. Ah, okay, finally. Okay, expression count 3. 1, 2, 3. A plus B. Okay, cool. Finally. Okay. I'm convinced. I'm convinced. Wait. So let me see what let me see what does that do. So I do peak, consume, at, and eat. So just peak. Okay. So peak is equal to token. So yeah. So peak returns a token. Consume consumes that token. And then at and eat just return booleans. Okay, yeah, that's good. So you have kind of a separation of your concerns too. So the peak and the consume can just focus on getting it and then consuming it. And that's all they do. And then at can give you information. Give you information back. And then expect can say that, okay, in this case, if it'll return an error if it doesn't happen. Okay. Okay, I'll start with peak and consume first. Or sometimes they call it next, right? Peak leads to a token. Next is a void. Just yeah. consumes it. At eat, and then can error also eats. Yeah, so it consumes it. Okay. We call it bump. Okay. Well, I'll do then add. Is it that? Okay. Okay. So it's kind of like in arrays where you if you modify it, there's one that actually has balance checking. There's the other one that doesn't have balance checking. It just does the operation. Okay, so I'm gonna start with peek and next. That just reduces the noise of doing peek is equal to token. And you called let me see, bump. Okay, let me write these two first, and then we'll go from there. So yeah, I think I'm gonna fix this right now. Let's see. And we'll make it a little stateful. So where is do I need peak and all of that from? We're getting it from the token list. So that's the output from the Lexer. Token list get. But it's stateful, so no, it doesn't maintain the currently the way it works is I'm just passing in the indexes, and then I'm returning the resulting index, right? So it doesn't hold the state. But yeah, let me add it real quick. Where is it? What is it called? So the parse results. Yeah, it's the. No, yeah, I think that issue that I just had like made me go like, yeah, I need to change that. Wait. So you said, do you have parser context with the current? Yeah, so I would put it on the I would put it on the parser context. That makes sense. So where is the parse results? All right, token list. That is parse storage, and then token index. Current token index. And then let's add a few of these. So you said it returns. What do I want to get back? The token itself, right? Okay, let's start with next. Next is the main one. So we'll do. Do we need to expose this in the public API? Probably not. Yeah, we can put this in the private API. Parser. It just has the current token index. Can make it global to not pass it around. Yeah, yeah. So my bad. Yeah. Make it global. I think I am still gonna pass it around. Yeah, I think I'm gonna pass it around. I want to avoid a global if I can. Let's see. I mean, I'm just gonna stick with this for now. Keep it in the parse result. Yeah, like a mutable reference. Because this is where I have all my stuff, and this is what like is produced, I guess. Yeah. Like right now, I literally have like it's just parse result. Just, you know. Let me see. So let me add the next. Let's see. Next takes in a parse results. Results pointer. It's a mutable parse result. Yeah, it does not do that. It's sorry, stateful. Next is void. And no, it does not do that. There we go. I don't know what the hell AI is doing. It's just because I originally had the Lexer. I called it Lex result. I don't know. Maybe I could have directly called it like token list, but I want to just have the status with it, whether like it failed or succeeded. Yeah, it's fair. This parse state is not a result of anything. It's just a state. Oh. Yeah. Parse results. Yeah, I mean, I think up until now, like the way I've been treating it, it's kind of like a result, you know. But now that like we're holding like state, yeah, it's more of a parser, yeah. Or like yeah. If anything, I could like separate it. Yeah, just have like a single one, and then maybe some like surrounding context that might be useful, and then the thing that we return from the parse would just be there's no point in making that separate. Yeah. Yeah, well, I'm gonna keep the name for now. I'm just gonna leave it. I guess the semantics of it kind of changed once I have this like this state that's changing. Let's see. Trying to think. So peak. Yeah, peak. Okay, so peak. Const parse result. Pointer parse result. Peak result. You want to pass the pointer back or? Wait. So what did you say? What did you say it was again? Let me see. Results in a token. Yeah. At token. Oh, is valid. Yeah. Okay, so I think for now, it's just going to be a token index. And then we just return. Yeah. I'm going to change it to like stuff in a second. I just want to start getting rid of, start using these two. And I think I'll naturally find the places where I can start using the other two. So let me think. Okay, so now no more returning token indexes. We just return the expressions and whatnot. So let's find everywhere we say next token or next index. Yeah, no more of that. Let's see. Token index. Probably should return a statement, right? That would only make sense. Oh, it's a definition index function index. So we'll add that in a second. Definition results. Definition index. Okay, let's see. So yeah, no need to do this anymore. Just return whether it's successful or not. Definition X. Oh yeah. I mean, I don't think we were using it anyways, but it's always useful to turn it back like that. Okay. Size T. Token index. Okay, so we got those. Okay. Okay, so we want to parse result dot no. Yeah, I'm doing like members instinctually. Peak parse results. Maybe I'll make like a convenience function just for that. Or in here, I could just no, that is, yeah, of course that doesn't work. Yeah, because it's a macro. That's definitely not gonna work. But, bruh, leave me alone. It's crazy. Let's see. Oh, wait a second. I could just do think semantically that makes sense. Okay, there we go. Now I don't have to keep incrementing every time I want to print it. Because this is just for printing for myself anyways, who cares? Alright, there we go. Index. Token index. Current index. Okay. Why are you trying to change that? This is AI, man. Okay. Okay, and I could probably simplify this too. Oh yeah, this is literally okay, for sure. Okay, I got you, yeah. I could do this, or I could just rewrite this thing too. Yeah, I'm probably just gonna rewrite this method. Current index. Okay, but the peak doesn't have +1 in this case. Okay. Yeah, that changes that. There's no more next index here. Parse argument results. Parse argument results. Range. Results. Result.status. Return results. Okay, so now there's no need to do any of this because it should already be updated. There we go. Result.status. Yeah, there we go. Result.range.counts. That. Yeah, I should fix this. So compare token type. Yeah, it's a pretty common method. Okay. Ooh, okay. That's for 7 hours. Dang. um. All right. Yeah, I think I'm gonna call it for today though. Yeah, I'm gonna go through this though and try to make sure that I update to some easier functions. It might take a minute, but yeah, that last issue with the whole looping index error was crazy. So yeah, I gotta fix this. But yeah. All right. I don't know if anybody's watching. Let me see if got any lurkers or anything. Okay, 2. And then let me see on YouTube. Laser state. That's why I should tell you. I mean, yeah. Like you've gone through it, so like you know. Yeah, I feel like sometimes I gotta like I gotta like go through my own issues to like figure it out, you know. But yeah, that like that error where the thing like messed up, I was like, yeah, no, I gotta fix it. So no, that's fair. Wait, how do I let me see. Okay. We're on YouTube. Let's see. And later on, rename parser results to parser, so it's less confusing. Oh, sure. Yeah. Whatchamacallit? Yeah. Especially since now it's holding state, and it's being queried directly. Then yeah, it's not a result anymore. So yeah. But yeah, I think my brain's kind of fried at this point. Yeah, I'm gonna be working the next few days. Probably not gonna stream, but I'll just be coding. So hopefully I make some progress over that time. So maybe next Monday. But yeah, I guess I don't have too many lurkers on right now, so everyone's chilling. But yeah, I appreciate Zaka hanging out and everything and helping. Yeah, hopefully I make some progress, you know. But yeah, I guess that's it. Later.